Good afternoon, all. Welcome to the workshop by SAE Shibpur chapter being conducted under the Centenary Celebration of the Department of Mechanical Engineering, IIEST Shibpur.
The Society of Automotive Engineers is a community of automobile enthusiasts of IIEST Shibpur. So before we begin with our today's workshop, I would like to invite Sushman Trivedi to give an insight about the SAE chapter of IIEST Shibpur.
Thank you. Hello everyone. Good afternoon. I am Shushmayan. I am an active member of Society of Automotive Engineers IIEST Shibpur chapter. Before we move to the most awaited workshop speeches, I just want to give you a quick overview of SAE IIEST chapter. In this presentation, I will be mainly talking about early days of our society, the goals we had set then, and the milestones we have crossed till now, yearly activities of SAE IIEST chapter, and finally, some glimpses of the amazing journey we had. Let's start. The dawn of SAE IIEST Shibpur chapter occurred in 2017 itself with the very goal of igniting the passion for automobiles in its apprentices. Since then, we have been pioneering ventures to engross ourselves with as much experience and knowledge as possible. The main inspiration behind foundation of this society was to participate in SAE Baha, which is a design cum racing competition organized by SAE every year. So, some of the automotive enthusiasts from IIST Shibpur decided to put together an amazing team who worked round the clock and put their best foot forward to design an all-terrain vehicle that is known as ATV. We shared ideas and dreams which eventually became reality. The society engaged itself and came up with the design of its first all-terrain vehicle in 2019. By the beginning of the next year, the team managed to fabricate the complete vehicle inside the campus. Not only that, from time to time, we have been conducting workshops and training sessions for the students. Our primary goal was to conceptualize, design, build, test, and validate a single-seated all-terrain vehicle. The design of the ATV mainly focuses on innovative solution to some fundamental problems faced while off-roading, at the same time giving equal importance to the safety guidelines published by SAE. Every vehicle consists of different systems which work together in perfect synchronization for the vehicle to run smoothly, and ATVs are no exception to that. So, we divided our team in some major departments, namely transmission, roll cage, suspension, steering, braking, etc. Our team has worked hard to design the different systems as efficient and innovatively as possible. Let's talk about the yearly activities of our society. Every year, SAE hosts Baha, which is a global intercollegiate design competition for small off-road vehicles, or more specifically, all-terrain vehicles. In 2019, though we already completed fabricating the vehicle, but unfortunately, we could not participate in the race due to emerging COVID condition. Since 2021, our chapter has been participating in the SAE Baha with huge success in spite of being one of the newest teams. Obviously, every team has a name. We call ourselves Team Automobiles. Every year, SAE Baha brings new challenges, and new challenges require innovation and updating. So, with proper health precaution, a part of our team has worked hard to improve and modify the already built vehicle even in this COVID condition. Besides working on the vehicle, second year members of SAE IIST chapter conduct regular interactive sessions for the freshers to pass on the light of knowledge and passion for automobile engineering. Senior members, rather the third year and fourth year members of the society, take the initiative to share hand-on experience of using different CAD/CAM softwares like ANSYS, Fusion 360, SolidWorks, MATLAB Simulink, IPG CarMaker, etc. Our chapter also offers experience on doing relevant research and producing coherent technical reports and presentations to its members. We focus on gaining of confidence, leading to articulate delivery of speech and answers. Last but not the least, the society conducts workshops and training sessions for all the student members of the society. We had organized an engine overhauling workshop in 2018. Now, let me tell you about the milestone we have crossed that have motivated us even more to move forward. I mean, our achievements. In SAE Baha 2021, we landed in top 25 nationally at Virtual Presentation Round, in top 10 nationally at CAE Design Round, in top 50 nationally in static events. To talk about our performances in SAE Baha this year, though Baha 2022 is not completed yet, we have already managed to find our position in top 10 nationally at CAE Design Round again. I know words are not enough to illustrate the adventurous journey of making your own vehicle. So, we have compiled some glimpses of our journey and prepared a mini clip showing how to make an ATV from scratch. Enjoy. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Now, I want to invite Tanishta to talk about the composition of our team.
Coming to the composition of our SAE IIEST chapter, the student body is divided as shown on the slide. We have the heads of the complete chapter, which are the student chairperson, treasurer, and the chief technical head. A part of that, we have 5 departments, as mentioned earlier by Sushmayan, and we have heads for each department. A part of these students can take up and be members of any of the department they wish to be. They can be members of more than one department too. We also have our guiding faculty with us who guide us throughout the process. Next slide. Coming upon the acknowledgements, we are really thankful to our institute, the Indian Institute of Engineering, Science and Technology Shibpur, to give us a space and the required workshop facilities to do the manufacturing. We are also very thankful to our Global Alumni Association, GABESU, for guiding us through and also providing with monetary support. We extend our thankfulness to Regal Services, Mr. Shiladitya Ganguly, CEO of Regal Services, for providing us with the monetary support when needed. We are also very thankful to our guiding faculties, Dr. Partho Protim De and Dr. Oritra Ganguly, for being there with us throughout the process and guiding us through. Thank you. Moving ahead, so the reason why we all are here today, we are having this workshop on the recent trends in automobile and engines, the Indian perspective. We all know about the advent of having mobility solutions connecting with the vehicle using Wi-Fi or Bluetooth automation, and also about EVs and hybrid vehicles. Here today, we will learn a little more in detail about all these things or on some specific topics, whichever our eminent speakers would be guiding us through. For this session today, we have a session chair.
So now I take this opportunity to welcome the chair of our today's session, Dr. Auditro Ganguly sir.
Uh, Thank you all. Myself, Dr. Auditro Ganguly, working as Associate Professor in the Mechanical Engineering Department of IIST Shibpur. It is indeed a privilege for me to act as session chair when eminent speakers will address the participants. So I am also eagerly waiting for to hear from them what are the challenges and what are the developments, state of the art developments which are taking place in this field of automotive engineering. As we all know that automobile engineering is going through a phase transition, and we are emphasizing upon the development of new eco-friendly vehicles, electric vehicles, hybrid electric vehicles, and today's speakers will be helpful because they are from industry and they will provide us an update about the recent trends and developments which are taking place in this particular area. So we will be waiting for them to join and listen their words. So with that, thank you all. Okay, so our very first speaker is Mr. Shomodipto Das. Indeed, it is a privilege for me to introduce him. Mr. Shomodipto Das is an alumnus of this department. He has completed his graduation from erstwhile Besu, now IIST Shibpur in 2010. Subsequently, he worked as an engineer in Maharatna Company, Coal India Limited, in electrical and mechanical division for about 1 year. Then he completed his MTech in solid mechanics and design from IIT Kanpur in 2013. Thereafter, he joined the famous company Renault Nissan Technology and Business Center India Private Limited as an engineer and served there till 2017 January. From 2017 January onwards, he is working as manager electric vehicles and hybrid electric vehicle system division in Maruti Suzuki India Limited, which is the leading car producing company in India. He has more than 8 years of experience in electric vehicle and hybrid electric vehicle technologies and currently discharging his responsibility in the area of electric vehicle and hybrid electric vehicle powertrain architecture, development of functional and diagnostic requirement for those vehicles, and system level simulation. He is also experienced in model based electric vehicle and hybrid electric vehicle control system development. So I am fortunate to introduce him, and I am patiently waiting for him to share his views about the topic with the participants. So I will request Mr. Shomadipta Das to address the participants. Please unmute Shomadipta Das, please.
Hello, hello.
You are
Am
audible.
I audible?
You
Okay.
are perfectly audible, Shomadipta.
Okay. Thank you, sir, for the introduction, your kind introduction. Good afternoon, all. Myself, Somadipta Das. As already said, mentioned that I am an alumni of this university. I have graduated in 2010 from this mechanical engineering department, and I'm very honored to be invited in mechanical engineering centenary celebration as guest speaker. Thank you, PPD set 2 for the invitation. Okay, uh, so I am going to cover the topic electrification of automotive powertrain system. So agenda for today will be Indian automotive industry trend, technology overview, EV work domain overview. Here actually I will give overview of EV powertrain, explaining different work domain. I think it will be helpful for students if they want to pursue their career in EV or HEV powertrain development industry. And then I will summarize the overall content. Sorry, is my screen visible?
Yeah, it is visible.
Okay. So, okay, now starting with Indian automotive industry trend. I will start with air pollution scenarios. Air pollution is one of the major challenge for not only our country nowadays, it's for entire world. As you may have known that India have around 35 cities out of 50 world's most polluted cities. And if we classify as per the contribution of different uh, sources of the pollution, it is found that around 51% of the pollution is caused by the industry, which actually includes construction industry, and 27% by the vehicle, and 17% from the crop burning, and 5% from other sources. So few other facts about the pollutions are 75% of Indians live in places that do not meet national air quality standards. And also, 1 in 8 deaths in India was attributable to air pollution in 2017. As we know, India has a low per capita emission of greenhouse gases, but the country as a whole is the third largest greenhouse gas producer, and which is topped by China and then followed by US actually. In viewing such situations, India have set vision for short term as well as long term to counter the pollution. So here you can see that bigger targets, like India will produce total projected carbon emission by 1 billion tons from now onwards till 2030. By 2030, India will reduce the carbon intensity of its economy by less than 45%. And long-term goal is to be carbon neutral by year 2070. Now, Indian automotive CO2 emission roadmap. Now, if let's see Indian automotive CO2 emission roadmap. As you may aware of Indian automotive emission norms, that is Bharat state standard, and in Europe it is Euro standard. From here, from this picture we can see that actually I was referring to this picture. From this here we can find that emission norms were little relaxed in rest of the India comparing the major cities before, but still we lagged behind European standards. From 2017, BS4 becomes mandatory for whole India. And then BS5 standard altogether skipped. Here you can see from BS4 it is directly BS6 has been introduced in 2020. Now aggressively actually government try to converge this emission norms gap. And for information, I think most of the here everybody already known about that BS6 standard or BS Euro standard. Still, BS6 is almost comparable with the Euro 6 standard. And increasing BS6 standard, it is required to reduce CO2 even more. For example, BS4 standard, here it is required 130 gram CO2 emission per kilometer. More than that, CO2 emission will not be acceptable. In BS6, it is 113 gram per kilometer. And this is one plot. This is one predicted plot. Around 2030, it will become around less than 40, might be by the regulation. So here we can see that BS6 is now inactive. Still, we are behind the European standard. They have already passed by. They have already in the Euro 6 standard for a long time, and they have also in the modification phase. So apart from that, not only this, not only that, driving emission also depends on different drive cycle. This emission, they here, as I told, that BS4 or BS6, they are tested in modified Indian drive cycle in city phase normally, that is MIDC. But as it is found that this lab test does not always reflect the real road scenarios. It is found that real road conditions may have 50% more emission in comparison to the lab test. So from 2023, real driving emission norms are going to be implemented, most likely in that RDE, Worldwide Harmonized Light Vehicle Test Cycle, that is WLTC, is going to be implemented to get the actually real CO2 emission. And not only that, in the emission perspective, also to reduce that carbon emission, also Indian government now encouraging EV cells to reduce CO2, as I told. Niti Aayog, the federal think tank, projected around 846 million tons of CO2 reduction by EV cells penetration at 70% for commercial cars, 30% for private cars, 40% for buses, and 80% for 2 and 3 wheelers by 2030. Now, as I have as I explained about different the condition of air pollution and government vision for 2070. Sorry, actually I lost. Okay. Now let's find the powertrain electrification technologies for reducing CO2. Okay. Here in this plot, we can see that classification based on electrification. In this graph, we find x-axis actually denotes the degree of electrification, and y-axis denotes that carbon dioxide reduction. So as we are increasing the electrification, it is that carbon dioxide emission will be reduced. So broadly here we divide electrification in 4 types of hybrid vehicle and 1 electric vehicle. So now starting with the micro hybrid. In micro hybrid and mild hybrid, electrical assistance and energy management. That is whatever energy here. First is micro hybrid. If I explain it, micro hybrid will be having start stop function, and it is having normal conventional IC engine. And also sometimes micro hybrid will be able to regenerate the energy when the braking will be done by the driver. So, but this energy in case of micro hybrid won't be that much used. That will not be used for driving or driving assist function. It will be mostly used for electrical loads like 12 volt, all lighting, IPC and everything, all the loads. For that, this energy will be used. But for mild hybrid, this energy, whatever is regenerating, apart from the start-stop functionality, whatever the regeneration energy it is getting, it will be able to provide assist to the engine. So by this way, actually, in mild hybrid, engine operating point correction, that is we call in our term, that is where that engine has best fuel economic region we can run that engine at that point, and rest of the load can be taken by that motor, or regeneration can happen. But from that full hybrid and onwards, electric drive capability will be there. For example, in case of full hybrid, that by that regeneration energy and whatever energy it has collected while driving, it can be used to drive the vehicle fully electrical mode, in electrical mode. Then plug-in hybrid is almost similar to that full hybrid, but here again engine is downsized, as I forgot to mention about the full hybrid also. It is downsized engine, but here the motor will be having more capability, and it it is having one bigger battery pack, so which is possible to be charged from the grid. So we can have around 50 kilometer uh, EV drive. And after that, all of course, we have full electric vehicle where no engine is there. It is run only motor and battery. I will explain in details. Uh, so classification based on electrification, again, that I have shown there before. And here it is like a small overview of the architecture of different kind of uh, hybrid vehicle, even EV. That is for mild hybrid. If you see this mild hybrid, it is kind of if you remove this battery and motor generator, the rest of the powertrain is similar to any conventional powertrain, that is fuel engine and transmission which goes to the wheel. And here one small motor generator unit has been added, which main functions, as I have shown previously, to start the stop and start the engine, and regenerate when braking is done. That inertia will be converted, and it will generate the electricity and stored in the small battery, which will be used for later electrical usage. Then if we go to the full hybrid, again motor is directly again connected to the transmission, to the driving wheel. So not only engine can drive the wheel, also motor is able to drive the vehicle. And plug-in hybrid also, here also you see that full hybrid and plug-in hybrid is having almost same architecture. And the battery, actually we have plug-in capability, that is battery can be charged from the grid. And of course after that, battery electric vehicle where no engine is there, directly from battery to motor to transmission, the power can be supplied to the wheel. Now again, HEV functions, for HEV there are different functions which actually reduces the CO2 of the vehicle. So here if you see the different functions like idle stop, electric torque assist, energy recuperation, that is regenerative braking, electric driving, and also battery charging while driving as well as from the grid. Those are different functionalities. And here you see that the where what is available, like for micro hybrid we cannot provide the boost, as I have explained before. It cannot have EV driving, and it doesn't have any grid connection for charging the battery. Where mild hybrid also doesn't have the EV mode and can doesn't need to charge from the grid. But HEV also you doesn't need to you don't need to charge it from the grid. So ultimately, with these hybrids, we can get CO2 reduction around, for micro hybrid, it is around 5 to 6%. For mild hybrid, it is around 7 to 12%. And for full hybrid, it is around 15 to 20%. And for plug-in hybrid, it is more than 20%. Because again, uh, it depends on that battery size that we put, so that we can charge it off from grid. Now, HEB classification, that I have already shown the classification based on that electrification. And now the motor actually connected, that motor can be connected at different places of the powertrain. So based on the motor connection at different places, we actually have classified that hybrid electric vehicle. For example, if we tell that is one hybrid is a P0 kind of hybrid, that means motor is connected to the front end of the engine by belt. So you can think of that micro hybrid will be like this, P0 configuration. And then P1 configuration, where motor will be connected to the engine crankshaft at the position of the flywheel also. So in mild hybrid, around you can say that mild hybrid normally have P1 configuration. And then it is P2 configuration. P2 configuration, motor is actually located between engine and gearbox. The clutch actually can actually disengage that motor from the engine. And actually this P2 configuration motor also comes with another clutch for different functionality. And after that, we have P3 configuration, where the motor is located outside of the output shaft of the transmission. So P2, P3 can be a full hybrid vehicle. And P4 is directly, that motor is mounted with that drive shaft. Normally that shaft is not connected to the engine. The other drive line normally connected with the motor. So normally P4 configuration is preferred for plug-in hybrid. So if you have any question in the middle also, you can ask, or later at the end also we have question and session. So okay, apart from that motor position, we classify that hybrid vehicle. Again, that full hybrid vehicle also we classify with parallel hybrid, series hybrid, and series parallel hybrid. So if you see this parallel hybrid, the parallel hybrid is, again, as I have shown that before, that engine can drive that power, engine can provide the power for the driving, as well as motor also can separately, independently can provide the power to the drive line. So actually what happens that at high torque demand, when the torque demand is very high, that time with engine, motor can also assist while driving. Not only EV mode, also this is also possible. So here engine downsizing can be possible. Now at low torque region, also what power can be provided by the engine, and also that power also can be transferred for charging the battery also. Now in case of series hybrid, engine cannot run the vehicle directly. It will always generate the electricity, and then by this motor only in this vehicle can run. So when SOC battery SOC is high, then power is directly provided by the battery to the drivetrain. When SOC is low, then power can be provided by the IC engine, and which will be generated and then again will be converted to the torque, will be converted to the driveline torque. Now in this case, as you can see that motor requirement is motor has to run for all the speed range, so motor will be very big. Full size motor is required in this case. Now again, in this case, series parallel hybrid, one power split device has been introduced between that IC engine and uh, uh, the transmission, which actually controls by which we can control that power directly from the engine to the transmission, as well as we can divert complete power for the generation. So in this configuration, we can have series and parallel both functions. So the advantages of series and parallel both can be achieved by this configuration. So okay, now I will now let's see about that EV overview. Now I discuss the different work area actually, which will be helpful for the students to identify the skill requirement for different areas. Now, if we see this is the development cycle, V cycle, that normally followed by most of the OEMs for developing vehicle, that is any electric vehicle or hybrid vehicle. So at the top, if you see, that is system engineering level, where that high level requirement will be prepared and specification will be prepared, and here system level requirement will be finalized. And while doing that, simulation, we use normally simulation by that we actually do that feasibility study, and then subsequently we will do that hardware and software level requirement also will be finalized here, and then a detailed hardware and software design takes place. In that case also, for software development, model and loop simulation also conducted all the time. And after that, software is implemented and hardware production is happened, then software and test phase started. The left phase actually design phase, and right phase is for validation or testing phase. So here bench test or hardware in loop test conducted after that development, and when it is integrated to the vehicle, then vehicle level uh, tests are performed for checking that system level requirements are met or not. So as I told that before, that system development, that is mostly we use a model-based system design and simulation. So here actually we prepare different requirements and specifications for controller, as well as that is very high system level requirements we prepare for controller, as well as for different type of components. And we, again, as I told before, that we finally need to meet the drive cycle that emission requirement, for example. So we put some drive cycle, and this drive cycle can be for meeting that regulation, or also we also sometimes put our design drive cycle for specific purposes. And with that drive cycle, we actually find that what is the vehicle range, for example, energy efficiency, performance, and component size required for this requirements to meet, then thermal requirement, vehicle functions, all these things we get as output, and we do that feasibility study by this, and finally we actually finalize the system level requirements by this simulation method. And while doing that, we normally use, there are many commercial packages are available, like MathWorks, MATLAB, obviously everybody you all know, and then GT Suite and AVL Cruise for system level simulation we use. Okay, now just I will tell about the different EV that about the EV architecture and key components. So here I have shown that, as I have told, that in system engineering, we have to develop different requirements, and that requirements actually consist of vehicle architectural requirement, as well as all components sizing requirement, and vehicle functional requirement too. And also, if some function fails or component fails, then failsafe function also, that is a diagnosis and failsafe. So here, for example, if we have prepared one EV architecture like this, so where we will have, these are the main components of EV, any electric vehicle, where we'll have one inverter, one motor, one DC-DC converter, one onboard inverter. Motor is for driving the vehicle, and DC-DC converter is, as motor and motor runs at, motor and battery, they are at high voltage, but we need low voltage 12 volt for our other applications. So we need one DC-DC converter which will convert high voltage to around 12 volt for all the loads. Then onboard charger, which will be using for charging for charging the vehicle, AC charging. And then again we have here electric compressor, and then electric heater maybe, and then this is fast charger, and then obviously battery pack. I will explain a little bit about these components also. So starting with the battery, traction battery. So there are different chemistries are available. So on the basis of chemistry, there mostly we divide in three, like lithium ion battery, and nickel metal hydride battery, and lead acid battery. Now lithium ion battery can have different type of chemistry, that is LFP, NMC, LTO, and NCA. Those are the different chemistry of battery cells we use. Okay, for a battery pack, normally OEM prepares the battery pack. So here cells are normally bought from suppliers. Cells are like battery cells that we use AA, AAA battery, that is normally NiMH battery. Anyway, similar kind of lithium ion battery cells are available. With that cell, we prepare a battery module. With some cells, we prepare for first module, and then that module we make battery pack. Sometimes we also, in a battery, total battery pack also, we can put cell. So different type of packaging are available. Then as it is also required to have cooling system. So based on cooling system also, it is divided in two types: air cooled or water cooled. And also battery, as you have noticed here, that orange cables are available there. Orange cable, with orange cable we denotes high voltage. So when the uh, battery voltage is less than 60 volt for DC, we call it a DC, low voltage system. And when it is more than 60 volt, we call it a high voltage system. So apart from that, there are many other components, so such as cells, as I told, bus bar. That way, all the bus bar are with that, all the modules are connected. That is actually connection between them, and wiring harness. That outside wiring of harness you can see, and BMS is battery management system. That is controller, vehicle interface, and current measuring device, isolation monitoring system, and main contactor relay, uh, coolant channel. Then component component overview. That main component, we have electric motor and inverter, and also inverter and DC-DC converter are also electrically, it is not same, it is that working principles are same, so we have put there. Also sometimes inverter comes with DC-DC converter, so I put in one place. Electric motor, on that, normally we use permanent magnet motor, and induction motor is as per construction. But normally we have been using permanent magnet synchronous motor for the vehicle. And on the basis of packaging, it can be inline with crank or belt driven. And also this motor can be air cooled or water cooled. So in motor, actually, it has one rotor and stator that I think you can see here. And apart from that, there are many other components are there, like position sensor, temperature sensor, output shaft, electric machine housing, cooling jacket, HB connector. As these motors are run on that field oriented control, normally PMSM motor, so we need sensors, and this is controlled by this is controlled by inverter. So inverter, that is inverter main work is to convert that DC power from the battery to AC for driving the motor. And also while getting that regenerative energy, it converts that AC to DC to charge the battery. And as I have already told, that DC-DC converter will be there. And DC-DC converter, actually, it from high voltage, it will prepare that low voltage. From around 200 300 volt, it will prepare 12 volt for all the loads in the vehicle. So for major components available in inverter or DC-DC converter will be IGBT MOSFETs module, and then control module, and then EMC filter, DC link capacitor, and HV current sensor. Now, apart from motor and battery, those are motor, inverter, battery, those are main parts. There are many other components. First, again, this charger. charger is any vehicle, electric vehicle. Most of the electric vehicle, you will see that it will be able to charge at by AC as well as DC. So for AC charging, we need onboard charger, which again, what it does, again, it converts that AC supply to DC with for charging the battery. And for DC charging, that it supplies DC, but main that controller is existed in EVSC. This actually this supply station, you can say, we call it EVSC. So for AC charging, we have normally it is charging current around charging power is around from 3.6 to 22 kilowatt. 3.6 is around, it will come our home charging 15 ampere socket, so we can charge if the vehicle is having OBC, then we can charge that vehicle by our 15 ampere socket. But as you can see, it is very small, so power is very less, so for charging one big battery it will take a lot of time. So apart from that, there are many standards that nationally, internationally has been followed. First, that comes CHAdeMO standard. This CHAdeMO, actually it is Japanese standard. They follow and they have prepared this standard, and they have prepared many vehicles based on this standard. And now CCA standard are mostly followed all over the world. That is combined charging system for AC and DC combined charging. So it is actually prepared in Europe, but it is being followed now almost globally. And for EVSC grid control, that is, this is EVSC, that is charging station kind of. And for grid control, it normally uses that open smart charging protocol. Apart from charging, there are other many EV components are there. So for example, electric compressor. Electric compressor in conventional vehicle, we normally see that engine drives that compressor for AC, but here it is run by another separate electric compressor unit, which is normally high voltage motor compressor unit. And then again, it has one electric water pump. Here also we have cooling circuit for cooling the electric machine, inverter, even battery. So for that, we need one electric water pump. For any ICE engine vehicle, engine only runs the water pump. Similarly, again, it is also having electric vacuum pump. For ICE engine vehicle, engine only prepares the vacuum in the vacuum chamber for braking. But here we don't have any. For the electric vehicle, we have to prepare. We have to use electric vacuum pump for creating that vacuum in the vacuum chamber. And of course, we have the display for showing the different kind of mode for vehicle running modes that for example, in HEV have shown different modes. It can show that power flow and all, and also SOC and different things are shown here. And then obviously that high voltage harness cable there. Now, as I have shown in the development V cycle, that different components are designed and then their testing also has been done. So for that, we need different test bench. For example, here I have shown one battery pack testing. So when we prepare one battery pack, it needs to comply with different many regulations, as well as it has to comply with our requirements. So For example, we normally electrical tests are performed. We normally broadly divide in electrical test and mechanical test on battery pack. In electrical test, we do short circuit test for cell level, module level, pack level. Even we send overcharge, and we check the battery. We check the battery life, how it is performing. That why whether that battery pack is showing proper um, uh, power limit and all, and whether it is providing that um, whatever power we are demanding or not, all the conditions, and what is the capacity and how it is decreasing capacity, even thermal behavior, and of course the BMS development, that is battery management system, which actually does all the work in the battery level, and also it also has its own diagnosis function. Similarly, uh, like electrical test, there are mechanical tests too, like vibration test, shock test, rollover test, penetration test. So here in that this figure, you can see that this is one chamber. Inside that we can put and abuse the battery, and we can send different type of power requirement and all, and we can check that how it is behaving. And similarly, vibration test, as you know, that vehicle when it runs on the road, there are many vibrations can be possible, and which uh, might be if some oscillation, some uh, problem can be found in the module or cell level at different vibration. So similarly, for motor inverter also, I have not shown here. For motor inverter also, different test pen setups are there, where we normally test efficiency map of the motor efficiency map, and also as per regulation we have to show the peak power, peak torque, continuous power, continuous torque. And also for in this also we it also includes lot of safety functions motor. So inverter control also has been checked. This now I will so that I have already explained that in different components, and I have given the overview. Now controller, if we see that in EV there are many controller. For example, there are many controller available, but I have only listed some few controllers which are important, which are actually for EV only. For example, EVC, that is electric vehicle control module, that is supervisory component control module, like whenever act pedal, brake pedal, and or selector different mode has been selected by driver, then EVC module will judge that what is the driver demand torque or something, and then it will accordingly communicate with motor, inverter, and all other components that what state it is, what is required now. Similarly, there are BMS, as I have already mentioned. BMS is battery management system, and uh, it normally it controls state of health, and or also state of charge. You can see that in meters that it shows the different charge, uh, what is the percentage of SOC is there, and also it also does the cell balancing, like when all the vehicle all the when battery is charged, all the cells they degrade over time, and it is not possible that all the time that all the cell will receive the same, having the same voltage. So some battery will be, some cells will be degraded. So at that time, to maintain the battery pack voltage at a level, it has to do the cell balancing, that is active balancing, sometimes do the passive balancing. And also obviously it provides that available battery available power to that electric EVC unit so that it can provide the torque. And obviously we have that inverter controller. It controls the motor torque while motoring action as well as in uh, regeneration action. And also there are ABC controller, that OBC controller, that is onboard charger. Onboard charger is connected to which actually controls the charging current to the battery. Actually what happens that when battery gets charged, its voltage increases. So continuously OBC doesn't only convert from AC to DC, but also modulate it as should to and all the cells and batteries having some capacity of taking current, so it maintains that. So next I will just I will go through that controller development part. So as I have shown that there are different type of controller. So when that controller are also developed in unit level, for example, BMS controller. For that, what uh, we do that unit level control model. This is one any control system modeling. We do that. This is a control model. This is plant model. So here we prepare the control algorithm. For example, for BMS, as I have told that uh, we have to estimate the battery health. So state of health algorithm will be modeled in Simulink, MATLAB Simulink. Normally we use MATLAB Simulink. So in that we prepared that SOH algorithm, and also we prepared the plant model. The plant model means battery model, which is required where this control algorithm will be running. So we prepare the plant model and we check that how it is working. So these are different development, like somebody will be developing plant model, somebody will be developing the control model, and integrating we check that how it is working, whether our function is working as per intention or not. So similarly for inverter also, like one control, for example, this is permanent magnet synchronous motor, so it runs on uh, it controlled by the inverter in field oriented control mechanism. So that control algorithm will be prepared here, and the motor plant model will be prepared here, and we can check that whether this control model is working properly or not. So everything here I have shown this modeling simulation. It is done in computer environment, that is simulation environment. Here no hardware is involved. When this control algorithm will be finalized, then this control algorithm, then this will be flashed in the software. Then software will be prepared accordingly. There are many software packages are there for preparing that, and hardware readable software it can convert. Then we flash that software in some hardware. Now when we put it in the any hardware like any ECU, then we have to check that how this as a hardware how it is behaving. So it is hardware in loop. Like here it is completely in the software environment. Here we put that software in the hardware. Now hardware will send that some actuation signal to the load, and also it receives some feedback from the sensors. And for that we have Hills system, that is this is called hardware in loop, and this simulator is there, Hills simulator, which can accept this signal. Hardware will receive the signal from the real issue, and here also like this we can prepare the plant model, and also we can connect the real load also. And from there also we generate the signals like feedback signals, like issue expects from the sensors, and it will be sent, so that it will complete that one closed loop setup for this control. So by this way, we prepared the software here, designed in this phase in modeling loop, and hardware loop, we normally test the software. So by this, I just came to the end where I just summarize the total whatever content we have explained today. Because this air pollution, as we have found that air pollution is major challenge for India currently, and for aiming, and as we are aiming for carbon neutral nation by 2070, there are different roadmaps, preparations are in progress. Electrification of powertrain is one of the major steps to reduce the carbon footprint in short term as well as in the long term. And then we have seen some classification based classification for electrification and also for hybrid, different type of hybrid vehicle. And then we have seen the development V cycle, for where we have explained that how that system is designed, system requirements are generated, and then those system requirements translates for the component level hardware requirement preparation. So different hardware I have shown, like how they are designed as per the requirement, and then software for that hardware, we prepare the software, and then we test all those hardware in the facilities, and software also simultaneously we test in the facility, and after that those are integrated and tested in the vehicle. So these are some references. With this, I like to thank you all for your patience. If you have any question, please.
All the participants are being unmuted, so if they have any questions, they can ask.
Good morning, sir.
Good morning. Good afternoon.
Good afternoon, sir. Sorry, sir. Sir, I had a question that I have already placed in the chat box, but I would like to say it now again.
Okay, I will check that.
Sorry, sir. So shall I?
Yes. Okay. Why can't we use a DC motor instead of AC motor? Anyway, see, but that's what I was telling, that even if you see any motor, no, motor all in motor, actually, if you see, that is you, it will be having UBW phase, right? So it is always converted to AC only. Motor always run in AC. So that commutation is done by this inverter. That's all. And in case of our permanent magnet synchronous motor, currently it is having almost providing the best efficiency at all the regions for low speed to high speed, which is not possible for all other motors. And it is very energy efficient. And as we are mostly concerned about the range of any EV, so efficiency matters a lot, actually.
And
Hello?
sir, is there any power loss while conversion of DC to AC in that inverter?
Yes. Power loss is always there. But again, that's what the different companies, there are many big companies, they are working like component companies to reduce that power loss as much as possible. And again, it will increase the cost also. So we have to balance. So normally, if you see that in PMSM, we get around more than 90% efficiency for any good motor, all the places. For conversion also around 90 to 95% maximum.
Okay, any other question from any participant?
Thank you, sir.
Okay.
Welcome.
So, okay, thank you, Somadipto,
Another
for
question,
your.
sir.
Okay, please.
Sir, in the hybrid electric vehicles, sir, in the different types of the hybrid engines, is the flywheel used the same type?
Yes, it is. Again, it is different for different vehicles. It is not uh, same for all the vehicle, all types of hybrid. Because normally, if you see normal hybrids in India, I don't see much. But there actually you have flywheel. But if you see that Toyota hybrid system, which is not here in India, and they don't have, it is different kind of things.
Okay, sir. Thank you.
Any other question? We can take one more question because of the time.
Excuse me, sir.
Yes, go ahead, please.
Sir, I have one question about a kind of fuel that was used in recent times, which I heard. So can I ask on that?
Okay, I don't work on that. Okay, you can ask, and then that's on then also.
Sir, some sort of a time back, TVS, they showcased a bike which would be running on methanol fluid. What is that?
Okay, see, actually now what happens that not only pure gasoline is not used currently, and government is trying to reduce that uh, this fuel fuel means this gasoline import. So what they are doing, they are blending with methanol and ethanol. So with that blending, actually, you can blend with alcohol actually. So there are some limits currently. There are some target around 20% uh, blending they are going to do for fuel. That will actually reduce the import duty, cost, importing burden of India. That's all.
Sir, does that mean the thing which they are showcasing, is it that it is a completely renewable source of fuel or just a mixture of both?
100% methanol I have not seen. 100% ethanol you can be used. I think there are some modification required, I think, in the engine. I'm not expert in that thing, but as per my knowledge, because it can be used. In case of ethanol, I have seen some.
Normally, we prefer to go for blending only. Okay,
Yes, normally.
blending, and actually the to reduce the oil dependence, government of India has also increased the percentage of these alcohols very recently. So 100% alcohol based, actually it is not there. Okay.
Yes, sir.
So with that, actually, due to the
Thank you, sir.
constraints of time, actually we have to we cannot allow the other participants to ask questions. But I must thank uh, the speaker for his excellent presentation, and he also touched upon all the aspects, starting from the pollution to the different architectural aspects of the hybrid vehicles and electric vehicles. So on behalf of the organizing committee, I extend my thanks to him. The participation certificate or the appreciation certificate, it is already prepared, but it is to be signed. So we will be sending the same to his email. And once again, I acknowledge his contribution. Okay, so Mr. Shomadipto for, and we hope that in future also he will give us the inputs which will be helpful for enriching our knowledge and also the enrichment for the students. Okay, so thank you, Shomadipto.
Thank you, sir. Thank you, sir. Thank you very much. Thank you all.
Okay, so we are having our next speaker with us, Mr. Obik Chattopadhyay. Again, we are fortunate to have Obik Chattopadhyay with us. Obik has spent 22 years in the automotive as well as oil and gas industries across the markets and cultures before he decided to go entrepreneurial. He has covered functions like marketing, business strategy, product planning, mergers and acquisitions, advocacy, and integration across various organizations like Maruti Suzuki, Caltex, ExxonMobil, Apollo Tires, and Volkswagen. Since December 2014, he is the co-founder and partner of a brand strategy and solutions consultancy called Experial, which is based at Gurgaon. Academically, Obik is an alumnus of IMD Lawson and XLRI Jamshedpur, which are very renowned institutes. And he has graduated in economics from Hansraj College, Delhi University. He is also a part of two of India's leading mentor platforms. He sits in the advisory board of XLRI Delhi NCR campus. So he also contributes regularly to ET Auto Business World, Autocar India, and many others. So with that background, I will request Obik Chattopadhyay to address the participants. Mr. Chattopadhyay, please.
Thank you very much for that very flattering introduction, Mr. Ganguly. Good evening, good afternoon, everybody. And firstly, it is surely a privilege for me to be here in your midst on the milestone of the centenary celebrations of the Department of Mechanical Engineering at what all of us Bengalis simply call as Shibpur. The subject that I've been asked to speak on is definitely interesting, but sandwiched between technical experts like Shomodipto and Anupam, what I will do is that I will make an attempt to share with you my perspectives on the subject of recent trends in automobiles and engines from an Indian consumer's perspective. So that is how I will start. I will share a short presentation that I have with all of you. Is my presentation?
No, not yet, sir.
Okay.
I think it will come.
Yeah, it is visible
has
now,
come.
right?
Okay.
Yes,
sir.
Okay, thank you. So I've actually called my short presentation before all of you as balance. Okay, and because the phase and age of our lives and times that we are living right now, balance is an extremely important virtue and value that we need especially you need, in your roles as engineers and people who are going to actually play a very important role in the way we live our lives tomorrow and the day after. So as I said, that this is an Indian consumer's perspective to the recent trends in automobiles and engines. I wanted to share an interesting meme that I got 2 days back, something that was created way back in 2007. Okay, so it said when Apple introduced the iPhone in 2007, it didn't set out to sell a phone. Nokia and BlackBerry were making fantastic phones. They were unbeatable. So Apple changed the rules of the game. It sidestepped the battle. To take over the world, it didn't create a phone that was also smart, something that BlackBerry, Nokia, and even Microsoft were doing. It created a smart device that was also a phone. Now, when you cut to 2012, and when Tesla came in, when we all heard of Tesla for the first time, the same applies to Tesla. Okay, so it says when Tesla introduced the Model S in 2012, it didn't set out to sell a car. Audi and BMW were making fantastic cars. They were unbeatable. So Tesla changed the rules of the game. It sidestepped the battle just like Apple earlier. To take over the world, it didn't create a car that was also smart, something that BMW, Audi, and even Ford were doing. It created a smart device that was also a car. So we live in an age of disruption, and I guess all of us are extremely lucky to be in this age, to learn from this age, and for people like you to start contributing to this age. You're engineers, but in your larger lives, you're consumers. Therefore, anything and everything that you do and you think and you want to do should be seen from the perspective of a consumer. Because then engineering actually ends up contributing holistically to life around it, to the entire ecosystem. And the ecosystem also ends up being far more holistic, far more harmonious, and far more enabling for every component in that ecosystem to live better. Therefore, your roles are extremely important, and therefore your understanding of the consumer, specifically the Indian consumer, is extremely important as you move ahead in your own careers and whatever you want to do in life from here. When we talk about trends, what really is a trend? Okay, to me, a trend is actually a combination of various factors that play their individual roles but together. And together they create a situation which leads to a reaction, leads to a change in behavior, leads to a certain change in choice, which is what we call as trend. And a trend is typically made up of 4 components, according to me. There's a country regulation, there's a corporate innovation, there is a community requirement, and there is a consumer aspiration. So all 4 of these have to work together to really create a trend. A trend cannot be an outcome of any one of them in mere isolation. It is a creation of all these 4 factors working together. So if you were to see what are the key trends in India right now, and I would hold up 6 key market trends in the automotive world. And when I say automotive, I also include engines along with it, because engines are integral to the automobile world. They are a subset. So to me, there are 6 key trends. The first is obvious, it's electrification. But in electrification, what is important to note is that electrification is happening at a massive pace in specific vehicle segments: 2-wheelers, 3-wheelers, micro-commercial vehicles, and buses. Electrification in India is not really caught up when it actually comes to 4-wheelers, and we'll come to that later. So in these 4 segments, India is playing a very, very important role in electrification. In fact, in December, what is interesting to note is that in India, we sold close to 200,000, which is 2 lakh electric 2-wheelers, which was more than 10% of the total sales of 2-wheelers in that month. So if you were to go by that trend, then that means electric two-wheelers are going to become definitely a part of the mainstream two-wheeler market, at least in the year 2022. Similarly, when we talk about buses, you'll see that a lot of buses that different cities and states are announcing as addition to their fleets are electric buses. Delhi, the city where I live in Gurgaon, which is a part of the larger national capital territory. Okay, the Delhi government has just announced induction of 300 new electric buses in the fleet. Mumbai has electric buses. Bangalore has electric buses. So electrification of buses, or specifically, let's say, public transport, is also becoming a big trend. Your last mile goods connectivity, which is through micro commercial vehicles, which are vehicles which are typically less than 1 ton, 1.5 ton in GVW, that is also becoming electrified, which is another important trend. So that's what's really happening in the area of electrification. Secondly, because of the last 2 years of the pandemic, affordability is going down, right? And that is actually seen, that's an outcome of the fact that raw material or input costs have gone up. Therefore, the trends are, what we see is the market for used vehicles has gone up, which is important to understand. Two-wheeler sales have gone down, which means the base from where you actually build the further pyramid of four-wheeler sales and the larger market is actually reducing, or right now it is suppressed. And the Indian market still sees very, very low penetration of vehicles. And as for the last data which I have, only 23 out of 1,000 people own a four-wheeler. Only 126 out of 1,000 own a two-wheeler. And what is really, really sad to know, that only 1.3 people out of 1,000 actually have access to a bus. Which means mobility in India, or the penetration of mobility in this country, is still very low. Every day, close to 400 million people in this country, they walk to work. And at the same time, if affordability goes down, it's a very disturbing trend in this country. Thirdly, when it actually comes to people buying individual vehicles, economy and safety are today two of the paramount factors or parameters which are used by the individual customer in making a brand choice. Till now, it was largely economy, but safety has got added, which actually says that the Indian market is finally maturing. It is growing not just in numbers, but it is also maturing qualitatively, which is a very positive trend. Fourth, and a very interesting trend that I have seen, is that of the rise of multimodal mobility, which means people have started using private vehicles with public vehicles. So private mobility with public mobility, private transport with public transport, which includes not just road, but also waterways and railways to help an individual move from point A to point B. And this is a very, very important trend, because the kind of solutions that many of you will be thinking of has to keep this in mind, that people would be buying individual modes of transport, not to use them all the time, but possibly to connect them to a public mode of transport and vice versa. The fifth trend that I see is there are multiple clean solutions. When Shommodipta was talking about electric mobility and electric vehicles and the entire engineering and architecture, yes, electric mobility is the flavor of the season right now in India. But there are multiple clean solutions which are being worked on. Shommodipta's organization itself, Maruti Suzuki, is a huge follower of the CNG solution as a clean solution. Along with electric, we also are talking about flex fuels. One of you asked a question about the TVS bike that was displayed, and TVS also is manufacturing it now. Okay, yes, we are actually talking about gasoline plus ethanol, right? There's not so much of methanol in this country. If we have more of methanol, it'll actually become a cheaper source of of mobility. But we're talking about gasoline and ethanol. Right now, it is E20, which is 20% of ethanol of ethanol can be mixed with gasoline. There are examples in the world of E100. Brazil is a classic example of an economy which basically runs on ethanol, right? And Brazil has been doing this for the last 30 odd years. It has not happened overnight. So when Mr. Gadkari talks about flex fuels in this country, there is obviously a larger plan in place, because India, being how complex we are, we cannot just have one solution to clean mobility. And lastly, we are talking about hydrogen. We already know about the National Green Hydrogen Mission, which was announced by the Prime Minister on the 15th of August last year. The sixth trend that I see is the growth of non-metro markets in the country. This is telling you that a lot of money is actually being made in places which are outside the metros. Okay, a lot of money is being made in the villages. Tractor sales have actually gone up last year, which tells you that there is a higher level of aspiration and affordability when it comes to the non-metros and when it comes to the farming community. And the growth of non-metro markets has a very important implication on the kind of vehicles, the vehicle architecture, the vehicle engineering, and other aspects of suspension and so on that you have to conceive to actually cater to those markets in the best manner possible. So these are the 6 key market trends that I see. There's a convergence that's happening, and the pandemic has taught us that the convergence is becoming more important. And it's a convergence, as I said, about the country, the corporation, the community, and the consumer. Now, when it comes to the country, okay, we as India, we have global pressures, right? We have the UN SDGs, the 16 goals that we have to meet, 17 goals actually, the 17 UN SDGs that we have to meet. All of us know about the COP26 that happened in Glasgow last year, and our Prime Minister has gone ahead and he has made commitments on a carbon neutral India in a certain point of time. So there is a pressure. I mean, if we were left completely in isolation, I don't think India would have actually taken those goals. But because we are part of a larger ecosystem, we have to. Along with that, right now, what we see in our country is there is really very little policy clarity when it actually comes to mobility of the future, right? So we have, on the one hand, our Prime Minister launching the National Green Hydrogen Mission. We have Mr. Gadkari talking about flex fuel, right? We have organizations like Maruti Suzuki, okay, going on the CNG route. And just recently, just a couple of days back, we had Tata Motors launching 2 new CNG vehicles, right? Within Niti Aayog itself, we actually see a difference of opinion. While one part of Niti Aayog says that India is going to be all electric, there's another part of Niti Aayog that says that we must explore a variety of alternate fuel sources, right? Because electric need not be as clean and as green as it really seems. And then we have a part of the corporate leadership, like in the case of Mr. Carlos Tavares of Stellantis, who says that this entire thing of going electric is more a pressure of governments and not really of the corporates. So in India right now, when you study, the entire policy framework is not very clear. So we have global pressures, and we have a certain lack of policy framework right now when it comes to green and clean mobility in the future. So the country, nevertheless, what the country really expects from this entire world of mobility is it needs to be self-reliant. We need to be resource secure. Whatever we prepare, whatever innovations we do, we should have some kind of a global reach, because it always acts as a good flag bearer for India as a nation. And then, of course, we have the clean goals to achieve. Now, for the corporation, for all corporations now, there is this added pressure of what we call purposeful profit, or we say profit with a purpose. Okay, ESG targets and goals are coming in. Okay, and ESG basically means environmental, social, and governance targets. So all organizations have to be led by these targets, and that necessitates all corporations to be more transparent, and that necessitates all corporations to be much more conscious about a sustainable environment and a sustainable community that they live and they operate in. Alongside, there is really no one way of going about things. So this is to actually use the famous saying of one of India's biggest spiritual leaders, Joto Mot Toto Pot. So while when we are talking about electric mobility and we're talking about batteries, it's not just lithium-ion batteries, which are the rage of the season. Like Mukesh Ambani and Reliance has gone ahead and invested huge money in actually a startup called Faradion in UK, which is actually talking about sodium-ion batteries. So we're also looking at massive disruption happening there. When we talked about engines, there's this very interesting engine that has been developed called Omega 1, which is modular in nature. It is truly, truly breakthrough. Okay, each module, the picture that I've shown is one module that weighs just 15 kgs, belting out 160 horsepower, 230 Nm of torque, 1,000 RPM at idling, and 25,000 RPM red line. Okay, and you can actually attach two of them. At 30 kgs, you have an engine which is actually churning out 320 horsepower, right? And we're talking about 460 Nm of torque. So the conventional engine is also being completely rethought. And that is an extremely positive step. The 4 or 5 days back, Mazda went ahead and again, they went ahead and filed a patent for a new Wankel engine. So the rotary engine, which for all this time was always known to be very, very fuel inefficient. Okay, they're actually looking at putting in 3 rotaries, right, onto a hybrid drivetrain to make the entire thing much greener and leaner. So there is not one path to the solution. There are multiple paths. They're operating at the same time. They're going ahead in the same direction. The final objective is the same. It is to make mobility far more sustainable in every country of the world. So the corporation basically is looking at action which is sustainable, profitable, replicable, obviously. So I can be in a position to actually replicate it across vehicle platforms. I can be able to replicate it across vehicle types, and extendable. For example, can I take it across to various operating conditions? Can I take it across to various operating countries? The community very frankly is talking about, I need mobility, or I need the automobile to play the role where it is inclusive, it is ecological, it is responsible, and it is multimodal. So when you live in a community, the community is impacted by issues like congestion. The community is impacted by issues like lack of parking. The community is impacted by issues like, employment or employability of people, okay, in a certain sector. So that is what really a community is bothered about. And eventually the consumer. So we always keep talking about this new phenomenon, or this new type of consumer called Gen Z or Generation Z. And you people are a part of it, because it is people who were born from 1999 and ahead, who are all part of Gen Z. And you people are a completely new kind of people. You think in a different manner, right? You don't go ahead and believe in conspicuous consumption. Okay, social media is a very, very important part of your decision-making process. You are always connected, you are attached, you are aware, you have access to information, you have access to what is good and what is bad in life at every nanosecond of your lives, right? But still, to reach out to you, what the consumer is really looking at is, if the consumer is looking at mobility or transport, which is, or an automobile, which is economical, it is safe, it is affordable, and it is convenient. That is really what a consumer is looking at. And then I now share with you certain trends that I see in this entire world of the consumer, which will actually help you possibly understand as to what kind of roles you will have to play when you move ahead in your careers. Okay. The first big shift that's happening, or the first big trend that's happening, is there is a customer and there is a consumer. And the two of them are quite different, right? The customer necessarily means there is an element of ownership, right? A customer is one who has to buy something to actually experience something. So the customer today is one who goes ahead and buys a two-wheeler or goes ahead and buys a four-wheeler, right? And for the customer, therefore, affordability is of primary importance. On the other hand, you have the consumer. The consumer is one who need not buy, but just needs to experience through usage. So when you see the growth of phenomena like Uber and Ola and any other ride-sharing platforms that you have around you, you as a consumer are not expected to buy a vehicle. You as a consumer are basically are required to only experience it. And therefore, you also, as an engineer, need to understand that if the consumer has to experience the vehicle and he or she experiences it on the back seat, about what the engineering of the vehicle really needs to be. Therefore, for the consumer, accessibility becomes a very important factor in making a choice, in making a brand decision. And this consumer is, there are various studies which actually define what really this consumer is, the Indian consumer is. For example, I've given the reference of one study by BCG of 2019, which talks about the 10 emerging trends of Indian consumers. So they're obviously the information centered shopping, they want to stay trendy. There's adoption of time-saving services, a full embrace of health and wellness, and growing interest in customized products. So these are the 5 key, according to that report, trends of the new Indian consumer. But there's a very clear distinction now between the customer and the consumer. Similarly, they're looking at efficiency and safety. In the previous days, you always thought that one came at the cost of another, but today, no. Today's consumer is not that. So when you're looking at efficiency, you're obviously looking at ease of operation. You're looking at economy, and you're looking at lightweighting. So when Shommodipto talked a lot about the way electric vehicles are, the electric vehicle architecture, one very important factor is electric vehicles, for their very architecture, become very heavy. Okay, and for that, lightweighting therefore becomes a very important input that you people as engineers have to bring in. The use of materials, the use of composites, the use of things like graphene, carbon fiber, and so on, okay, are going to gain greater popularity as we move ahead. We may have to look at other kinds of ways of actually constructing the entire body shell. On the other hand, you have safety. And safety is becoming a big factor, as I talked about even earlier. Today, every year, at least once a year, there is this huge debate, a national debate across various television platforms and social media platforms on how safe Indian vehicles are. Because there is this organization called Global NCAP that goes around testing Indian vehicles. So safety basically means it's got to be adaptive, right? So there's active and passive. There is also this growing concern for pedestrian safety. And also you need to have manual overrides over electronic safety systems. That's the other balance that you as engineers need to play when you actually get into automotive engineering, the balance between efficiency and safety. The third balance is reliability and durability. When we talk about reliability, it is to do with two very important aspects. One is there is growing digital complexity in the automobile. Even if it is a two-wheeler, there is much growing digital complexity. There's a lot of over-the-air updates that are meant to happen, right? There's a lot of things which happen, okay, basically when you're in operation, as what they say is fly-by-wire or whatever. And that is the digital complexity which needs to be extremely reliable. The other is reliability basically has a positive impact on ownership costs. The more reliable the vehicle, the lower will be the ownership costs over the ownership period of say 5 years or 7 years. On the other hand, you need to balance it with durability. Durability is to do with the physical usage, and therefore it has the style of the vehicle has an important impact on durability, and also it definitely impacts the resale value. Now, if a larger number of two-wheeler and four-wheeler sales are happening in non-metro towns, which really don't have proper road networks, or the quality of roads are not as good as those in the metro cities, the way you design the vehicles is going to be extremely important. Otherwise, the ownership costs are going to go up. Also, because of that, we see the current trend of SUVs becoming very popular across the country. They are now the second biggest segment in four-wheeler passenger vehicles, just after the smaller hatchbacks. And in fact, actually, if the SUVs or the SUV styles were available at the price points of the smaller hatchbacks, I'm sure they would have overtaken them in style as a segment. And lastly, of course, is the resale value. The resale value is a very important parameter which plays on the mind of the consumer when he or she, or the customer, when he or she is actually making a brand choice. Therefore, as an engineer, you again have to have this balance between reliability and durability. Private and public. Today's consumer has a mix of private and public modes of transport. Recently, I was reading an interesting news item which said that a 19-year-old hacker called David Colombo actually went ahead and gained access into 25 Teslas, and he remotely controlled them for some time, because he gained that access actually through a third-party vulnerability, some software, a third-party software, which allowed him to control 25 cars remotely sitting at home. So he used the horn whenever he wanted to. He opened their doors, he opened their lids, he opened their bonnets, he switched them off, he switched them on. And that is really scary stuff. So when we're talking about connectivity, when we're talking about digitizing our vehicles, what is extremely important is the security of those vehicles. How can we build better firewalls? And therefore, you as mechanical engineers will have to work with guys in software day in and day out to ensure that. And what you create, the physical manifestation, has to have a very close, or not a very close, it has to be completely in conjunction with the digital or the software manifestation on which it operates. On the other hand, privacy of information. While I want connectivity as a consumer and I'm sharing information through a software, I definitely want my privacy. And that is going to become a big issue with consumers like all of us in the days ahead in India. On the other hand, when I look at public mobility, I'm definitely wanting it to converge very well with my private mode of transport. Therefore, I'm looking at options like platooning, and I'm looking at options like portability, where I can switch on and switch off from my private mode of transport to the public one, and so on. Lastly, I come to engine and energy. Okay, because there was this one subject of engines. And well, there is this transformation that's happening from the engine into becoming what is now, very frankly, the propellant. There was a point of time when the consumer, okay, had a larger interest in the engine. as to what is the engine capacity, how much of BHP, how much of torque, what is the size of the engine, and so on. Earlier, we used to have only typically two choices. Either your engine ran on diesel or your engine ran on gasoline. And then slowly we had engines also running on CNG. Auto LPG never really took off in this country. Today, it's slowly changing, and the entire trend is moving forward to what is my source of energy. So when you talk about the engine, there are obviously three aspects of the engine. And those three aspects are what I call the 3E, which is the economy, which is how lean does the engine operate, the enthusiasm, which is how well are the performance, the dynamic performance characteristics of the engine. And lastly, what are the emissions, which I as a consumer may not be really bothered about right now as an Indian consumer, but then there is a government regulation, and obviously there is the community requirement, and therefore I'm also concerned about what are the emissions, because over a period of time, I may actually be given an incentive for buying a vehicle A, which is safer, and B, which is obviously far less polluting or as green as possible. Like there are incentives today to buy electric vehicles. Tomorrow there will be incentives to buy hydrogen vehicles and so on. So on the other hand, is this entire concept of energy, where I as a consumer, I'm quite source agnostic, right? I am not really concerned about, whether I should be using a CNG, whether I should be using ethanol, whether I should be using methanol, or whether I should be using hydrogen or biodiesel or HCNG or so on. I'm quite source agnostic. I'm moving into that stage when the source or the propellant of my vehicle really doesn't matter that much. But what really matters to me are aspects like range, because I need to be very, very sure of how much I can travel on that particular source of energy. The safety, which is a big issue with any new mode of energy that I use for moving myself around from point A to point B. The ballistic safety, of course, is extremely important. And third is the life. So when one of you asked about using ethanol as a mix with gasoline in engines, yes, the metallurgy has to change. And if you study the E100 engines, which are used in Brazil, the metallurgy is quite different, okay, from the metallurgy that you would use in, let's say, 100% gasoline or 100% diesel engine. But do I want to give away one for the other? I don't. As a consumer, I look upon the engineer in you to give me the balance. So I want to use a hydrogen vehicle, but I don't want to rob myself of the enthusiasm. Okay. So like people are nowadays talking about, CNG becoming the new diesel in this country. Yes, that's sure. Okay. Because diesel sales have fallen by more than 60% over the last 3 years. And CNG is obviously going up in numbers. But will I get the same level of enthusiasm or dynamic performance when I'm driving a CNG vehicle? If I don't, then the CNG vehicle or the CNG options, okay, would be restricted to either fleets, which is taxis, or they would be restricted to people who are not really enthusiasts. But what really makes the automobile world interesting is that small section of people who are the enthusiasts, because they actually go ahead and drive people like you into designing and devising better products. Therefore, that balance between the engine and the energy is another balance that you need to work on. And that is, again, another important consumer trend, which is expected that you people need to understand. So to end, so that was my brief talk with all of you. To sum it all up, as I said earlier, there is no one solution. The consumer, just like the policymakers, just like the vehicle makers, is also in a state of flux. to paraphrase Karl Marx. But at the end of the day, there are various options available to us. All those options are feasible. All those options are viable. All those options are moving towards that one single target of sustainable mobility for all. And with that, I actually end my my session here today. Any questions? Most welcome.
Thank you, Mr. Chattopadhyay, for your wonderful lecture. So, I will actually open the room for discussion. So, if any participant has any question, he may definitely ask the speaker.
Hello, sir. I'm Shubhadeep Kole. I have a question.
Yes, sure.
So we keep talking about electric vehicles so much, but there are several reports that claim that in the long run, the CO2 emissions for an electric vehicle may be greater than or the same as fossil fuels or of the cars that run on fossil fuels. So why don't we take that into consideration when we are like innovating?
Very interesting question, Shubhadeep. And and that is why there is this open debate right now. In fact, just last year there was a detailed report done by Volvo, okay, in which they actually, they shared data of working on a Volvo electric vehicle vis-a-vis a Volvo ICE vehicle, and where they ended up coming to the conclusion that an electric vehicle may not be actually as green as it is typically made out to be, because there are lots of conditions in the electric vehicle. The way you actually end up putting together an electric vehicle right now is not the greenest, okay, because you need to mine a lot of things, you need to process a lot of things which are not done in the greenest manner. Secondly, the source of electricity that you are going to use for your electric vehicle, at least in our country, is not going to be green at least till the year 2050, right? And after 2050, yes, majority of the power produced in this country is going to be green, is going to be renewable. But till then, we are going to still be largely dependent on coal power, which is the reason, Shubhadeep, why even in a planning body like Niti Aayog, there are two schools of thought. There is this one school of thought which says we need to actually look at more greener and more sustainable modes of mobility, which is also why I think the government last year announced the National Green Hydrogen Mission. Hydrogen right now is expensive because storage is expensive, production is expensive, but then just the way the cost of batteries dropped from say $1,200 per kilowatt hour now to 130 or even close to 100, okay, over the last 5 years, so would the cost of hydrogen or production of hydrogen. And then you can have hydrogen also in the form of HCNG, which also is a very, very clean, sustainable mode of running mobility. So the answers are still out. We still don't have clear answers. There is this current trend of electric, and personally, I think India needs to have its own solutions. We just can't ape the West. There was a point when we aped the West about gasoline and diesel. We're again making the mistake of aping the West when it comes to electric. We continue to look at examples like Norway. We look at examples like Denmark. Okay, now those are countries where power generation itself is renewable, where the use of renewables in everyday life is almost to the tune of 85 to 90%. And we are talking about a country like ours where it is not even 10%. So the jury is out. The battle is still on. And as I said, and that's how I ended, says we will continue to be in this state of flux for quite some time.
Yes, sir, that makes sense. Thank you.
Okay, any other question? Anybody? Okay, Mr. Chattopadhyay, actually, I completely agree with you and wholeheartedly support your views because as an academician, we also come across these questions many places from in our day-to-day life. Now, what you have pointed out, that is, I very much agree with that because in India's socio-economic conditions are totally different from what is prevailing in the than in the advanced countries. Now, definitely, if we try to take it without or copy it rather, in a, without thinking of the solutions or the possible outcome in future, definitely it may be a problematic one. Because if you see uh, electric vehicles, what you are pointing out that even today, majority of the electricity generation is coming from the coal-fired power plants, and it is causing a huge amount of environmental degradation. And we are trying hard that we should improve the efficiency also. Now, because even if we go for a conventional Rankine cycle, that means the efficiency may be maximum of the order of 30%. That means 100 units of energy, 70% is lost. And the major portion of it is going in the form of greenhouse gases and of course the pollutants. So if that same electricity we are again using for these automobiles in some form of other, ultimately it is converted into mechanical work, then out of that 30% also the effective performance utilization will be some 15 or 20% or even less. So, to me, it doesn't appear to be a very wise solution. And definitely, rather than that, we should think of using the hydrogen-based systems, especially when the fuel cells have developed significantly over the years. And when I last visited the US, so I was also quite surprised that they were utilized in a very good way in powering the tanks in Afghanistan. As we all know that in case of during the time of a war, actually the capacity of a what I should say the mileage what a tank gives is very poor because its weight is very heavy, and you cannot go for storing a huge amount of fuel tank. And whenever you are entering the enemy territory, you don't expect that there will be a fuel supply station, or even if it is there, the enemy will not keep it intact. So this is a problem in a normal warfare. So they were utilizing the fuel cell based systems for that of the tanks, and that has performed very exceptionally good in Afghanistan. So this actually I am talking about 7, 8 years back. Now the technology has evolved further. So to me also it appears that hydrogen-based systems can be a better solution compared to that of the electric vehicles. We can go for CNG, we can go for hybrid systems, but totally converting into that electric vehicles as of now for a country like India may not be a proper and very feasible solution as I feel. But of course, we have to follow the government directives, government regulations, and whatever things are coming up, we have to accept it. So I really enjoyed your lecture, though I am as a session chair, because actually I found a person who pointed out these grassroots issues, which are very relevant for a common man, and it is really very important also. When we think only from the engineering perspective, also some issues come. But when we talk in terms of the common man as a consumer, uh, that part is also very important. And what you rightly pointed out, the difference between a customer and consumer, that part is also very important in the modern scenario. So definitely, on behalf of the organizing committee, I will express my thanks, wholehearted thanks for your nice presentation. And definitely there will be a participation and our appreciation certificate. Actually, that is yet to be signed, and we will be mailing it you over the in a very short time. And thanks for your valuable contribution in this particular workshop.
Thank you
Thank you.
very much. My privilege entirely. Thank you very
And
much. Stay safe. Thank you.
and thank you. So we
I
are
think
having a
the next speaker has not joined yet. Okay, so we can go as per timing.
okay. So actually, I think we should wait for a few minutes for the next speaker to join.
Hi, this is Anupam here. I have already joined.
Oh,
He
okay.
has joined.
Okay. Thank you. So we have the privilege to have our next speaker, Anupam Bhattacharjee. He is the Vice President of Tata Technologies and also an researcher in the field of electric vehicles. He is a passionate business leader with 23 years of global automotive industry experience, including the overseas experience in leading countries like US, Germany, France, and Japan in digital and or engineering services, key account management, innovation and product management across various organizations, including very reputed organizations like Wipro Technologies, Mahindra and Mahindra, Tata Motors Limited, etc. He is an alumnus of Jadavpur University and Loyola Institute of Business Administration, and he has pursued his PhD in electric vehicle branding from Indian Institute of Management, Ranchi. A United Nations speaker, a writer, and a global thought leader in electric mobility, connected software-driven vehicles, customer experience, Industry 4.0, and cloud migration. So with this short background, we are indeed privileged to have Anupam Bhattacharjee as a speaker with us, and I will request Mr. Bhattacharjee to address the participants. Mr. Bhattacharjee, please.
Am I audible?
Yes, sir. You are very
Oh,
much audible.
great. So, Mr. Ganguly, thank you so much for giving such a nice introduction. I think it was too big an introduction and too flattery, but anyway, thank you so much. And I would like to also thank Professor PPD. I think he has been kind enough. He has been interacting with me. And I would like to also thank all the students for being here today. So if you don't mind, Professor Ganguly, maybe how many people are there? I can't see from here. And
Actually, till now, we find 73 participants are there, which
okay,
include actually the student members from this institute and also from some outside.
okay. Is it possible if I ask any question, anybody can answer, or everybody
Uh,
is muted?
Actually, it is muted, sir. What I
No,
will
sir.
request.
Sir, Ganguly sir,
Yes, please.
everybody is unmuted now. When the lecture start, I will mute them. Okay. Before that, it is
Okay,
unmuted.
fantastic.
They can unmute themselves.
Oh, fantastic. Because
Okay.
what happens, if I only talk and it is very difficult for me to understand whether people, because I can't see anybody's face. So maybe one or two times I'll be asking a few questions and maybe if you can open or unmute them, someone can, answer my questions.
No problem, sir. That is most welcome, sir.
Thank you so much. First of all, it's a very, very happy feeling for me. I'm among so many students because once you leave college, it is always about your professional life. But today I'm among so many students of Shibpur, and I believe some of them are from Jadavpur as well. So it gives a great feeling for me that I'm among so many students. This would have been even better for me if I have actually done this face to face, but at the same time, keeping the current circumstances in mind, I think this is better or this is okay for everyone. So, what I'm going to talk about today is about. Yeah, anyone wanted to say something? Okay.
No, sir. Actually, please continue.
Okay. So what I'm going to do today is I will talk about three things. and I will talk nothing from the book. So all the students just relax, just hear what I am saying. I'm saying. You don't need to keep anything in your mind, and I will not ask any question from your books. Okay, it is all common sense, because when you move to industry, it's not about what you read in the book. It is about how you understand what is happening in the industry and giving your innovation in the small or big work, whatever you do within the industry. And third thing, I will talk mainly on auto industry and give perspective of connected vehicles, electric vehicles, and software defined vehicles. All these three things I will explain. One thing I'm missing, maybe next time I will talk about that, is about autonomous vehicles, because I don't have much of time. So within the time, these three things are too many for one lecture, but I will try to give you the perspective which will help you, choose your path, career path, if you want to come into this kind of field. So before I start, I will show some two videos, and then I will get into my presentation. So how do I share them? In this share, same thing?
Yes, there is a share option, sir.
Okay,
And
okay,
see,
okay,
I made you the co-host, so you can
okay,
click. So
okay, okay, okay. First, let me, okay. Can I share my entire screen?
yes, yes.
Okay. Full screen. Okay, okay, I got it. I'm sorry, I'm doing Cisco WebEx for the first time, so sure.
Sir, no issue.
Is my screen visible?
It is coming. Yeah, it has come.
Oh, fantastic. So what I will do is I'll get into the presentation, and then I will show two videos and then get back to the presentation. Okay. So 1 minute. Oh, yes. So what I'm going to talk about is the technology shift in auto industry, and are we ready for the future? So as I've told you, I will first talk about connected vehicles. I will then talk about electric vehicles and give certain perspective on what is happening to the electric vehicle industry, and what is the implication to India and what is happening in India. Then a very interesting topic, I will talk about the software-defined cars. This is not known to many people. Even the largest of the auto companies are struggling to work in this area. And last but not the least, I will take a few questions, whatever comes from the students. So I will talk about the connected vehicle, but before that, I will show a video. I don't know whether the sound is reaching you, but let me try. Is the sound going? Can you hear the sound?
No, sir.
No,
No,
sir.
sir.
So actually, while sharing the screen, in the right side of that window, there is an option for uh, unmuting the audio of your presentation.
Okay, okay. I
You
will.
have to reshare again.
Okay. Let me get into that. How do I go there? Cisco, I can't see.
So if you have joined using the browser, then you need to go back to the browser.
The browser. Yeah, it is coming. Yes. I will do stop sharing, and then again I'll do sharing.
Yes, sir.
So here there is automatic option. Oh, sound. Share your computer audio. Yeah, I have done that now. Let me know if I'm now going to show about the connected vehicle program of GM OnStar, which is the oldest one and the most successful. Is it audible now? Is this audible now?
So we can't see your presentation.
Oh, 1 minute.
So you have to share the presentation.
Yeah, I'll do that once again. Is it visible now?
Actually,
Yes, sir. Yes, sir, we can see your screen.
Is the video visible?
Yes, sir, it's audible.
OnStar. Hi, this is Jill at OnStar. How may I help you today?
Was the volume on? Could you hear it?
Yes, sir.
Okay, so what you had seen, it was too quick, but I will just give you a few highlight of what you were seeing. This was a video of GM OnStar. So GM has the largest, the oldest connected vehicle program in the world. About more than 10 years back, they had come up with this connected platform. So what you saw is if car meets with an accident, immediately the location and all those things are known to the call center. If somebody has, needs some concierge services, or somebody is in some panic, there are certain buttons, it goes to the OnStar. If you are driving on the highway, you are hungry, and if you want to buy pizza at a discount, it is there on the OnStar. So, there are a plethora of services that come in the connected vehicles. Now, I will show one more video and I'll get into the theory of it. Then you will understand what it is all about. I will show you a video of a company, a Chinese company called Coros. Okay, they are right from day one, connected vehicle. Just try to understand what they're doing. Okay, could you hear?
Yes, sir.
Fantastic. So now I'll get into the presentation. I hope you could understand that a connected vehicle, I am sure many of you will be knowing what is a connected vehicle, but the kind of features that are coming, the kind of use cases that are coming are so boundaryless and so many that nobody can say that I know everything in the connected vehicle, and use cases are sort of finalized. So I'll quickly talk about what is a connected car. Okay, If you see a slide here on the round, you can see that you have first vehicle ECU, that is the electric control unit. Basically, that is the part which manages the entire vehicle inside. It doesn't talk outside. That means all engine components, all different sensors that are there within the vehicles. Then you have vehicle telematics control unit, which is more about the location. It's not about the performance of the vehicle, it is about the locational services. Okay. Now then you have telematic service provider. These are basically these round things. Now telematic service provider is the one which takes all that data, vehicle data, which is from the ECU, and the locational data, and put it into the cloud. And then through the mobile network operators or MNOs, it gets into the cloud. Now, when it comes to the cloud, it is not about only data of the vehicle. It is about the CRM data. It is about the ERP data within our organization. Everything gets clubbed together. And that data then is consumed through websites or mobiles and so on and so forth. There are basically two purposes. One is the lifetime value of the customer is increased by using this platform by the auto OEMs, and total cost of operation for the customer goes down. Now somebody will ask me how the total cost of operation will come down for a customer who is using this vehicle. Now it is very simple. Say for example, if the temperature of the oil in a car goes up, that means there is some more friction happening somewhere. So some bearing is wearing off. And if this information reaches the server fast, and server says that, look, there is some problem in this car, stop this car and do a prognostic check and then correct it. Now the engine failure doesn't happen. So basically the customer is saved from a major problem. So this is how the prognostics happens, and this is how the connected vehicle system works. So this is nothing but that only. But by doing this, which are the areas that connected vehicles affect is one is navigation. Now navigation is a very high-fi level of navigation. It is not the navigation that we are very much habituated with our mobile phones. Fantastic or futuristic connected vehicles give turn-by-turn navigation. It is so perfect that it is not like Google. Sometimes we get confused whether to go left, right, or which exit to be taken, or maybe somewhere there is a dead end. That kind of navigation cannot work in connected vehicle. Or just imagine an autonomous vehicle. So these are very different level of navigations. Very specialized companies are into this navigation. So it is about direction, it is map, and this is real-time map. Just imagine the same thing when there is an autonomous vehicle and it is actually real-time moving. Okay. Then vehicle management, in terms of maintenance, your notifications, remote diagnostics, which I gave an example. Then B call is nothing but breakdown. So as soon as the car breaks down, the information goes to the auto AM automatically. You don't need to call up, and all the rescue operations start happening. And of course safety, because speed, distance, how many times car braking is happening, rash driving is happening or not, all this information comes in this kind of system. Then of course entertainment is a major important part in terms of music, in terms of videos, in terms of many other things. Now what happens, those screens which are visible for the driver, you cannot run a video while the car is moving. But at the time when the car is stationary, this can run and this can become a big entertainment place. In fact, there is a controversy going on in Tesla. Tesla was allowing video game while the car was moving. So which American authorities said it is not possible, but very recently Tesla has stopped that. Okay. Then fleet management. Fleet management is about who have hundreds of vehicles, where their behaviors, their fuel consumption pattern, and so on and so forth. And there are remote applications. I'm not going each and everything because it will take long time. But what I'm saying is, through the connected vehicles, so many services are possible and are happening. In India, very few connected vehicles are there. In the sense, very few auto OEMs are selling connected vehicles, and if at all they are selling in the high-end variants. So these are going to come, and this is what it is. Now, little bit on the technical side, those who are little interested about understanding what is a connected vehicle and what are the different layers inside a connected vehicle, all you can understand so far that connected vehicles are not only pure engineering or mechanical engineering cars. There are in today's cars millions of softwares, lines of coding that are there. There are hardwares. When you talk about TCU, basically telematics control unit, nothing is nothing but pure processor based computer inside. And the more advanced car it becomes, there are actually supercomputers inside cars. Today, inside a Tesla, the kind of computer that is there, that is really supercomputer, and very few supercomputers are there, even in big labs. They're so high-end computers, because real time so much of data play is happening. It is not always on cloud. Locally within the car, so much of work is happening by the computer. So here, those who are not only thinking that they are only mechanical engineers and do only mechanical job, I think I can put a caution that you should think it differently. Mechanical is one part. Just imagine, engine is gone means 10,000 parts are gone. That means 10,000 part design is gone. In an electric vehicle, there is a motor, there is a there are millions of lines of codes, and there is a battery. So straightforward, 10,000 engineering part design is gone because engine is not there. So as budding engineers, as future technologists, I would recommend that you try to get into the technology part of this, coding part of it, hardware part of it, embedded part of it, and then start seeing everything together. So what you see in this slide is basically a combination of all these things that are there inside a car today. So if you see at the top, user layers, you are seeing that laptop, mobile, tablet, third party application, kiosk, call center, and all that. So now you will say what car has connection with all these things, but there is a great connection among all these things, because you don't know through which gadget the user of the car will get into the car and try to extract or push data. So it is not about only extracting data or understanding what is happening with the vehicle. It is about pushing also. Say, for example, your car is stolen and you want to immobilize the car. Just push one button, the car is immobilized, and thus car cannot be taken away by the driver. Or say, for example, from far away, you just want to flash your headlamp. Okay, or you want to just switch on your AC before you reach to the car. So all these things are possible. Everything is through mobile. So that means your mobile is not only mobile, your app is not only app, it connects everything within the car. Okay, it can be mobile, tablet, any application. It can be even WeChat. WeChat is not very popular out here, but if you just imagine, if you go to China, it is WeChat. Here, WhatsApp. So everything is integrated together. Okay, this is how things are happening. And then of course UI, presentation services that we are talking about, all those devices have different ways of presenting data and actuating information or actuating a command. So for all these devices, the kind of UX is completely different. So that needs a different skill altogether. Okay, now the third layer is basically the use case layer. Connected vehicle services. When we are talking about different use cases, there are hundreds, thousands, millions of use cases. There are only a few out here, but this list is very, very small. Okay, then analytics services. Say, for example, we are talking about trend analytics, predictive analytics, and so on and so forth. I already gave an example of what is predictive analytics. If I can tell that the car is going to fail because of the parameters that I'm collecting from the vehicle, that is nothing but prognostics. Okay, so that is what is also possible through all the data that is coming, and AI ML that are there using TensorFlow and so on and so forth. You actually train the model and then take the output of that model to do many things using analytics. Then on the black, this thing here, we are talking about the enterprise integration. Now, this is nothing but within, companies, you have CRM, you have enterprise applications, or all these, or you have even MES, you have manufacturing data. So all these information that are there, if they are combined with the connected vehicle data, then only you can monetize all this data. All these data are kept separately and they are not talking to each other. You cannot do prognostics. Say, for example, you understand that a particular vehicle is heating up, some bearing is gone. Then you have to tell to the CRM system, to the nearest dealer of the car, I mean, wherever car is there, that there is a problem with this and please go and rectify it. So dealer from the nearest dealership will call this car up and go and tell him that there is something problem. So I will come and correct it. So this in turn is helping the dealerships to increase their revenue, at the same time helping customers to reduce their overall cost. So this is how everything is mingled, everything is intertwined, and this is how the overall system works. And then you have social, in today's days, you guys all are connected to your Instas, Facebooks. I'm sorry, Facebook is a I mean, maybe for the little older generation, but Twitter, Insta, everybody is connected. But how your system, your home, your car can be disconnected from that. So connecting all these things is also important and part of this connected system. And last but not the least, where you keep all that data. It can be in cloud, it can be within your premises, some can be in cloud, there can be hybrid models. So there are different models depending on the strategy you take. Okay, so and very important part on the left hand side, you see we are talking about security, because if the system is not secure, from outside somebody will come and enter your car and do everything wrong with the car, and you will lose control of the car. So security is a very, very important part of this thing. And SSO is nothing but single sign-on. So if you are doing a Google login or Facebook login, it should work all across. Okay. And last, on the right hand side, if you are seeing, it is about testing. Since you are seeing this is a very complex system, if you don't have testing of the individual components and all components together, there are very high chances that things will fail. Okay. So in a nutshell, technologically, this is what the whole ecosystem is. So quickly, this is the last slide about connected vehicles. I will not delve deep into it because this is already too much. Maybe if you know already this is fine. But for the first time, if you are seeing it, this is too much to handle on the first day. But know it, this is how the changes are happening. And I thought this can be useful. Okay. Now, when you create a platform, see, connected vehicle is, as you have seen, it is quite complex. It is not one or two things. This is a combination of thousands, millions of things. And as I've told you, it is millions of lines of coding. So what are the attributes of the connected vehicle platform that are there? First is about vehicle data. So sensors capturing data within a vehicle. There are so many. I think all our mechanical engineering friends will have all idea which are the kind of inputs that come from the vehicle. Okay. Then ways of deployment. So all this, how do you deploy, whether it is a public or a private cloud, in-house and all that. Then connectivity. When we talk about connectivity, it is about internet connectivity, and it is also about crisscross connectivity of all the data sources that you have within the organization, and interfaces, because when you connect all these data, and if it is there in a data lake, you have to consume that data to increase your profitability or lifetime value of the customer, right? So you have API gateways. You don't give the complete database access to anybody. You only give API so that the consumers of the data will pick up only the data which they are allowed to use. Okay. And scalable, as you know, connected vehicles, if there are 1 million cars, tomorrow that 1 million will become 2 million, then 3 million, 4 million. If the platform is not robust enough, it cannot handle so much of transaction. Just to give an idea, in a Tesla, a packet goes every nanosecond. Are you imagining what is the kind of data that is flowing from the vehicle to the cloud? So to handle that kind of data, the platform has to be really, really robust. And last but not the least, the most important part is about analytics, running, AI, ML, basically two, as I've told you, two things, increasing the lifetime value of the customer and reducing the, customers' overall expenditure. So this is about connected vehicle. I will give a pause here. Any questions from anybody? Or it was interesting or it was too much? Anyone?
Any
Sir,
participant?
it was quite interesting, sir.
Okay, so 2 minutes. If anyone wants to ask anything, then I will move to the electric one.
Any participant who wants to ask any question?
And sirs,
So,
is it interesting? Yeah, go ahead. Go ahead.
yes, sir. So about connecting vehicles and connecting them with applications on the Google Cloud. So there is this issue regarding, even though we are having cloud storage, but somewhere all the cloud storage is also into physical servers. So if we go for scaling up this particular connecting vehicles theme, won't it cause us to have a lot more space for servers? Like we need to create many servers to handle all the data if there are many number of cars who are using the concept of connecting vehicles.
Yeah, good question. As I've told you, every day is data. Okay, and nobody in this actually connected vehicle space keeps data within their premises. So you cannot keep on adding servers within your premises. But what happens? All these cloud operators, there is no upper limit. Okay, whether largest cloud operator is basically AWS or Amazon, and the second largest is Azure or Microsoft, and the third largest is your Google Cloud Platform or GCP. Okay, so everywhere connected vehicles are on cloud because not only because of storage but because of the AI/ML platform they also give with the cloud. Okay. Now, say for example, Google has a TensorFlow, which is their AI/ML platform. Okay. So you can do training of the model, and you have also many ready-made, trained models available already within these clouds. So cloud is the way to go, and you are not bothered as an auto OEM. You are not expert in storage. So why you do even venture into that? It is always on cloud. Okay, so
Okay,
I will not take any question now. Quickly, I'll get into the electric vehicle. This is also an interesting
Actually,
area.
one question actually was put in the in the
Okay,
chat
I can't
box.
see that. I can't see that. Can somebody read out? Well, how to see this?
Gaurav, he asked using
What is the
IoT.
question?
Is connected vehicle is using IoT?
Okay. Connected vehicle is the big brother of IoT. IoT is very small. It is moving IoT. So, those technologies that are used in IoT are very primitive because most of the IoT devices are stationary. The technologies that are used in IoT are different. But in connected vehicle, the languages that are used are Kafka, Scala, which are used generally for moving IoT platforms.
Okay.
Okay, it is much more complex than a IoT device.
Okay.
Okay.
Okay. Okay, sir. Please proceed to the electric vehicles.
Yeah.
In the
Quickly, I'm
end,
very.
in the end, if we get time, there may be more interactive sessions, sir.
Yeah,
Okay.
424. Yeah. So electric, I will quickly talk about electric. See, if we think that electric is pretty new, it is not. I have put all the images of electric vehicles which were available since 1899. In fact, Carl Benz, the first car he made was an electric car. Even the first Porsche was an electric car. Okay, those were before 1900. So more than 100 years back, there were electric cars. Okay, but after about 1910 around, all electric vehicles had gone. About 1906 and all, there were 40% market share of electric vehicles. But if you see out here, all these electric vehicles since 97, 99, GM EV1 came, that also few thousand they had sold and everything was scrapped. Electric had completely gone. The first big bet on electric was taken by actually Nissan when they launched Nissan Leaf in 2010. Even then, it was not picking up. But the big change had happened when actually Tesla came in and they started, position electric vehicles in a very premium segment. And they made a point to position the car in such a way that it is very aspirational. And they also gave 300 plus mileage. Earlier it was hardly 100 kilometers, and that was it. But Tesla changed everything, and you know what is happening across the world today. I will gradually come to that and also tell you what is the number that is happening today. Now this is about future. Okay. Now Tesla Model 3, if you see, is the highest selling electric car across the globe, and you know why it is. The kind of features it come up with, the kind of positioning it has, the kind of range it has. It is amazing. But it doesn't mean that that's the only place. If you see here, there are many other companies. Rivian, they are coming in trucks. If you see, the picture out here, it is basically Rivian. They have just launched. They will be coming soon. These are in India, we call them pickups, but basically they are called trucks in US. Okay. And this is Tesla Cybertruck, not yet launched. It will be coming. Basically, again, pickup. Okay. Ford pickup again is coming. But on the left hand side, what you are seeing is basically the truck. Tesla is Tesla Semi, and there are companies like Nikola. You can see the blue N. That's Nikola. So they are coming up in big time commercial vehicles, and these semi trucks are really, really big. 40 ton, 50 ton, 100 ton kind of trucks. So if you see, I mean, electric vehicles are coming almost every segment. Okay. This is about little numbers just to give an idea how things are happening. Tesla this year just sold 1 million vehicles. Now 1 million is 10 lakhs. Okay, which is huge number. And just to give an idea, in a world scenario, in a year, about 75 to 80 million cars are sold. Okay, but if you see Tesla's market capitalization is 1 trillion more than anybody else. They touched 1 trillion. The next best is Toyota, which is about 274. Volkswagen 122, BYD 113. If you see this slide out here, Daimler is 82 billion. Tesla is 1 trillion. It was more than 1 trillion, just it has come down few days back a little bit. Ford is 81 billion. General Motors is 76. BMW is 67 billion. And Tesla is 1000. Just imagine what people are betting on this auto company. Okay. Global EV sales all-time record high, almost 100% plus increase has happened in 2021. 6.3 million electric vehicles were sold globally. And you can, if you see this slide, here you can see some of the countries where electric vehicle share has gone drastically up. Norway almost 70%, Iceland 40%, Sweden is 25-30%, and Netherlands is more than 10%. Okay, I'll give you a little scenario about India also. As I've told you, 2021 EV sales 6.3 million. Global EV share is about 7.88%. But see what is happening, percent is only Tata Motors. This year Tata 15,000 electric have taken a target of 50,000 electric vehicles.
Sir,
Just see the quantum jump that is happening.
Sir, actually the sound is sometimes breaking. Actually, if there is any nearby device. No. Okay. Okay. Please go.
Okay. Okay. I think I will keep my phone away. Maybe because of my phone. Am I audible now?
Now it is perfectly audible, sir.
Okay, fine. I am just moving my phone away. Okay. Anything that you missed here, previous slide or this slide that I should
No,
repeat?
no. Actually, only one or two sentences only. The last few.
Okay. Okay, fine. So what I'm saying here, in this slide, you can make out that India penetration of electric vehicles are really, I mean, is really small, and it has a potential to really go up, and it will happen in next few years. So little bit about Indian market. If you see 1994, REVA was first formed. That was the electric vehicle. We probably know it. But since then, till 2000, I think 19, nothing much had happened. India, we were selling hardly 40, 50 electric cars, in a month. The real change had happened actually in 2019 and 2020, where basically Tata Motors, MG, Hyundai, and Mahindra to some extent had come up with electric vehicles. Now, if you see 2020, for the first time, lithium and 19 and 20, first time lithium and batteries started coming in, because these are the batteries which has very high energy density, and they can, in a small space with a little weight, it can actually hold a lot of charge. So the automatically, as soon as lithium came, the range actually went up. Okay, which was 100 kilometers in India became suddenly 300 kilometers, in 20. These are the different models that are that gradually came in 2019, 2020. In the commercial segment, of course, Mahindra Trio came, and if you see the pricing out here, there were a lot of researches actually done. I'll tell you about quickly about what was the research outcome. But what had happened is 2020, the change that had happened is the offerings were far better. You had the right pricing, you had the range which was good, and also government started giving good subsidy. Say for example, till 31st March in Maharashtra, 2.5 lakhs per vehicle subsidy government is giving on the list price. Okay, so that's a big amount, and the registration charge is only 100 rupees, because this 100 rupees becomes 4-5% of the vehicle. I mean, if it is a costly vehicle of 15 lakhs, the registration itself will cost 4-5%, which is quite high. Okay. But electric vehicles, all these government subsidies had come, and it was far better. But I was talking about a research which we found that if a vehicle customers are ready to pay 20% extra if electric vehicles are costed from the equivalent combustion ignition vehicle. So now what happens if you take a small car, say 5 lakhs, and you take 20% of that, that is 1 lakh. 1 lakh you cannot make a lithium ion battery and give it to the customer. So if you see the success, it never happened on a small car. But at the same time, if you see Tata Nexon, which was about 13-14 lakhs, 20% of that, about 2.5-3 lakhs, which was good enough for electrification. So these are certain market insights that actually helped some of the companies to come up with the right product.
Sir, actually, I will interrupt you once. Actually, that means in the compact car segment, actually, electrification may not be a very feasible option as of now.
As of now, you are right. You are
Okay.
right. But
Okay.
over a period of time, it will happen when battery prices will come down, and if there are enough volumes. So that's what Maruti will find it difficult, but they are also working to bring something less than 10 lakhs. But
Okay.
it is little difficult. You ask the right question, sir.
Because I when these prices come, actually, I was also thinking that why it is not for the entry level. So you gave the answer. That prompted me to ask the question. Okay, sir, please continue.
Yeah. So basically, EV market challenges I have mentioned out here. unavailability of long range electric vehicles. Today 315 kilometers are available, but customers are even asking 400. So there are certain range of vehicles which are coming 400 with 400 plus mileage. Then high cost, as entry level cars are not feasible, you are not having too much of entry level options at all. Not then unavailability of an integrated policy. Now what happens, every state if you go, the SOP, the shops are given are quite different actually. If you come Maharashtra, it is good. If you go to West Bengal, may not be as good. Maybe, I mean, some other state is even better. So it is not uniform all across. Central government is putting all the best efforts to actually bring the EVs to 20% level by another 2-3 years. Initially they announced that by 2030 100% vehicles will be electric, but there are certain challenges in that, because if everything converts into electric, we have a huge number of people who are employed by auto industry and their dealers and so on and so forth, and contribute 4-5% of our GDP, directly indirectly. So if suddenly everything becomes electric, no, those skills we will not have, and those people who have different skills, employment will be a challenge. So government take a measured call and they say that okay, we will make 30% by 2030. Okay, but at the same time, Mr. Modi has very clear thought that if we need to be reduce our import bill, we have to move electric, and that is going to happen in next few years. Of course, these are government things. I am not talking about that. One more information I'll give you. Electric vehicle, the base thing is the cell, which actually combines together to create the battery. In India, not a single cell manufacturer is there of lithium ion. So every cell that is used in India is imported from China or Japan or Korea. I mean, mostly in China. So that is the kind of thing is happening. So Tata is trying to do one thing. This is a public news only. I'm just sharing with you. We have created a consortium where Tata Chemicals is working on the battery chemistry, lithium ion cell that I was talking about. Tata Auto Component is working on battery packs. Now cells combined together along with the cells and thermal management and these things put together, put into a box, and then it becomes a battery pack that Tata Auto Component is going to do. And Tata Power is working on the EV charging infrastructure, and TCS is trying to create the overall technology backbone for running this whole thing. So while you don't you don't see these things in your eyes, but these are the work that is happening behind, Of course, there are many private companies who are also working in terms of moving their current ecosystem in electric. If you see the photo out here, Jeff Bezos, while he was in India, he had launched many three-wheelers who actually deliver the Amazon goods are electric. In Bangalore, you can see that Flipkart has also committed electric vehicles for their goods movement. Now, I will quickly talk about, I don't know how much time I have. I will quickly talk about 4 Ps of electric vehicle market. Now, what happens, those who have a little management background, you will see that there are 4 Ps of Kotler in marketing. Okay, price, place, promotion, and product. Okay, now for EV, this is of course my understanding. So there are actually 4 Ps of EV market leadership. One is the product. Of course, the technology. I will just talk in the next slide. What is the kind of technology that are there when I talk about the software driven vehicles or defined cars? Because many things are there already in Tesla. Okay. Then product, which segment? As we just discussed, sir had also discussed that entry level, why there are not electric vehicles. So there are certain challenges. If as a EV manufacturer you need to be successful, you have to really know which segment that you need to enter, and then only you can be sustainable, otherwise it is not. And the kind of premium that you can charge, as I told you that there were many researches, and it was found that about 20% premium people are ready to pay. But if you are charging 30, 40, 50% premium on the equivalent car, people are not going to pay. And last but not the least is the innovation. Now, innovation all across in electric vehicles, whether it is battery innovation, whether it is lithium ion, sodium ion, or any other solid state batteries that can hold more charge and better charge holding capacity, charge capacity, quick charging. All those innovations will make or break the future of electric vehicle companies. I have mentioned about software defined cars. Just 2 slides after this, I will explain that. That's a very interesting concept. And real-time onboard analytics, which again I mentioned earlier, the kind of supercomputers that are there inside cars are really very different. They are real supercomputers, and they are really doing AI ML every now and then, and they are giving instruction to the vehicles to work accordingly. Now positioning. Now it's a very important P, because if you see Tesla never positioned as cheap car. They were always premium. Okay, and they were in the beginning only car. Now seeing them, many companies tried to get into that premium car segment, and they actually failed. And there are examples of certain companies who actually took a different path, and they were highly successful. I'll talk about three companies in fact. One is Tesla, which we all know is greatly successful. Second thing is Rivian. Rivian, instead of cars, they went to pickup trucks in US. And their valuation, they hardly sold few, vehicles as of now, but their valuation is roughly about 100 billion plus without selling anything. Okay. Whereas if you see Faraday Future, if you see Byton, all these companies, they all came in the same segment of Tesla. But the customer expectation, they could not manage well. And as of now, they are not successful. They're really not successful. They are, of course, trying hard. NIO is one company, again, Chinese company. They have been little successful in certain, I'll not say little, they are quite successful in this space. Now, third P is about partnership. It's very important that partnership for an electric vehicle company. Now, as I've told you, partnership because of battery. Tesla even today has a large contract with Panasonic. Panasonic makes battery for them. Because what is happening is auto companies, nobody is committing their own battery making. They are doing battery making, but cell they are not getting into. BMW also made a comment few months back that they will not get into cells, because the technology is shifting so much. You never know, you spend billions of dollars in creating a facility and tomorrow it becomes quite obsolete. Second point is about motor. Now for electric vehicle, motor is like the heart, and it has to be super efficient and super efficient. I'll give an example. There is a logo you can see below which is called NIDAC, NIDEC. It's a Japanese company. They make motors for Apple iPhones for vibration. Now they are becoming significantly important in the electric vehicle space, because the motors that are required in electric vehicles are of different quality, and different technology altogether. Many places they use BLDC or brushless DC current motors. There are certain places they work on AC. There are certain places, AC motor with, permanent magnet, without permanent magnet. So here, although we are talking about a car, we are talking about, pure mechanical engineering thing. But if the kind of contribution of electrical engineers out here is immense. So unless otherwise you have the right partnership in terms of motor, third point is about infrastructure. Charging infrastructure, you cannot make your own infrastructure across the country, length and breadth of the country. So then contract manufacturing. I had put one company called Fisker. Okay, they are doing contract manufacturing with Foxconn. Foxconn is making electric cars for them. Okay, so this is the kind of change that is happening. Last but not the least, a lot of partnership with academia company. I mean, engineering colleges like Shibpur, Jadavpur, and all other places really need to get into it and contribute to this whole thing, because there is a lot of work to do. And last P is about the policy. Now you all know that Tesla is saying reduce my import duty, and our Indian companies are saying that why to reduce import duty when they are importing from a different country instead of making it here. So there are different government policies that are being worked on, and push and pull is happening. So that's important. As a company, we need to manipulate the policies in such a way, rather not manipulate, adjust the policies in such a way that it benefits the country. So how much time do I have? I have 2 more slides. Can I continue?
Sir, you can get another 10 minutes comfortably. No problem. 455 comfortably. If it is slightly more, no problem.
I don't know whether people are enjoying what I'm saying. Any comments from anybody?
Any participant? You have any comments?
I can't see anybody's face, so it's very difficult for me to understand whether I'm talking blah 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 or I'm talking sense.
Yeah. So actually, sir, it is an interesting lecture, sir. We are getting some feedback from the participants.
Okay. Thanks. So I have 2 more quick slides, and this is very important. I would recommend that please pay attention to this. This is if someone of you want to take your career to the next level of work, which is not even done today. Please pay attention to these 2 very simple slides. There is nothing technical into this. I just want to make you think very differently. Okay. Now just imagine what is automotive engineering and what has happened in last 100 years. Okay, so 100 years back also same car with that engine, drive shaft, wheels, it was like this, and today also it is like the same. So basic car in last 100 years, frankly speaking, not too much of disruption that has happened in other technology industries. Say for example mobile phone. In last 10 years, what has happened is unthinkable, unimaginable. Different technologies. But in car industry, I'm from automotive industry, but I'm still saying that 100 years, not much has happened. Now I'll tell you what has happened. Of course, refinement has happened in the cars. Earlier, if the NVH, noise, vibration, harshness was too high, now it is too refined. No, light quality has become so good. Earlier, probably you could not have read a newspaper sitting inside a car, sitting behind. But today you can do that. If you see the road noise and all that, if you sit inside a BMW, there is absolute silence inside the car. Okay. Also, many features, convenient features that had come. There were certain screens that had come, but car remained car. Same engine, same belt, same control, same steering wheel, same everything. Improved HMI. HMI is human machine interface. All that thing you see out there in front of you while you drive the car. Performance, of course, engines became bigger, they became more silent, they became more powerful, they became more fuel efficient. And the other important thing that had happened is in terms of emission standards, because last 100 years emission standards have really gone leaps and bounces. If there were certain standards 10 years back, it has of course BS2, BS3, BS4, BS6, Euro 1, Euro 2, Euro 6, all these things have happened. Okay, but what is to be seen out here is, if a car you wanted to give a feature that used to be defined before designing the car. Say for example, I will have a car with VX variant with different features. Say for example, cruise control. I will give VX a VX of control. But unfortunately, I didn't buy the VX. I had bought the LX car, and I want to put cruise control in the car. Is it possible? Anyone, can you respond? Is it possible to bring in new features in the car if that had not come with that feature in the beginning, even today?
Offline market modifications can be done.
But for very limited features, not cruise control, can it be brought?
No, I
No,
don't
sir.
Which
think.
are basic to the car. Yes. So there lies the status quo. Okay. There are many other things. Can you really bring Apple CarPlay inside a car if it is not coming with that? Can you really control AC from outside? Can a car be made connected car by aftermarket fitment? All these things are not possible. Okay. Now Tesla actually had challenged the status quo. They said we will not define a car in the beginning in terms of what are the features that I'm going to give. They said I will create a car in such a way that I first define what are the hardware that I want to put. Okay, so they took us drawing board, and they decided that we will put this 25-30 sensors, actuators, and so on and so forth. They also said that since inside a car there are many switches which actually actuate many things. Okay, say for example cruise control. Why I'm saying it is not possible, because for cruise control you need a software system, you need outside hardware system, you need actuators inside the car like switches and also so on and so forth. But Tesla said I will not keep any switch, I'll keep only touchscreen. Okay, so first they actually defined hardware. Okay, say for example my car, a Shell, will have a leader. Now leader is what? Basically radar with a laser. Okay, it actually senses what is there all across. Then Tesla said I will have cameras all across, I will have even camera facing inside, without knowing what he will do with that. Okay, they said I want to make a very robust hardware system of cars. Now I'm just bleeping those dots. They are just representing certain hardware that they are putting inside. Then they said that I will put cameras, I will have RPM meters all across wheels, I will see temperature, I will have complete touch screen inside and no, not a single knob or not a single actuator. I will have smell sensor, I will have light sensor inside, outside. Like that, they did brainstorming and they did a complete mapping of what are those hardware they are going to keep inside a car. And not only for today, next 10 years, 20 years. Okay, at level 2, level 3, level 4. The software.
Sir, again some voice issues is coming. Sir, please look into it.
Is it better now?
Much better, much better. Please go ahead, sir.
Okay. Okay. So actually they defined a software platform in such a way that you can onboard any hardware into that. So your platform can onboard all the hardware that you have talked about, not only of today, even for tomorrow. Okay. And then they had put a supercomputer behind, NVIDIA processors, they have NVIDIA processors, high-end supercomputer within the car. They are basically brain for the platform, which picks up all this data real time, and real time they do analytics and give output. Now Tesla has something called autopilot, which is basically a semi-autonomous kind of vehicle. So if you sit inside a car and put it to autopilot, actually it will drive on its own. Okay, they tell that don't leave the driver's seat, be there. If there is an emergency, just use this. Now I'll tell you what has happened, how this software driven vehicle works.
Sir, it is not
So,
audible.
and he was driving the car.
Actually, again, there was a temporary disruption.
Am I audible now?
Well, perfectly, but sometimes it is going, sir.
Maybe because of my internet connection. Maybe I really don't
uh,
know. So what happens? This software and hardware combination in the vehicle, it works in tandem and it works locally, and of course it also works with the cloud. The example that I was giving is autopilot driver. He was such a nerd. He had put it in autopilot, left the driver's seat, sat behind, and unfortunately that car met with an accident and the driver also died. Okay, now this was a very big embarrassment for Tesla. So what they had done is within one day, they had activated the camera inside the vehicle, and if the camera senses that there is no driver in the driver's seat, the car will be stopped and it will be kept aside. The car will not move forward. Okay, now this is a feature they never thought, but as soon as this problem had happened, they had pushed this feature through internet, through the connectivity, and it was activated on the next day. So this is only possible in a software defined car. Say for example, I'll give you some examples, some more examples. Tesla recently came up with a wash mode. See, in US, if you want to wash your car, you just drive the car inside a washing garage, and it will get automatically clean. Now, if your glasses are down, entire water and soap and all that will come inside. Now, about 2-3 months back, they had brought this wash mode, and in the touchscreen that mode came up, because you don't need any switch out there, no, just this touchscreen, this mode came up. So if you press that mode, automatically all glasses and everything will get sealed in no time. So before you enter, everything is by one switch, everything is done. Now this is a feature they thought, the use cases they thought, and they had pushed it, and it was up within no time. Okay. Then very recently, about 15 days back, they had put a feature where there was an indication on the touchscreen again that your vehicle left hand side tire is wearing off more. Now just imagine how it is possible. What they had done is they have those RPM sensors for each and every wheel. So when the diameter of a wheel comes down, and for the same movement of the vehicle, it will move in a different RPM. So they notice that different four wheels have different RPMs, and immediately whichever is gone up because of the tire wear, they say that that wheel has a tire wear problem. Just imagine kind of use cases that can be pushed because it is a software driven car. It is not a hard car like any other car in the world. Now recently, again during the Christmas 25th December, by which actually your entire car will all the lights will flicker and the loud music will come up, and it will start as if celebration and dancing and all that. So your place garage will become a disco, because the Tesla you can program that way. Not only that, they have given a console by which you can go and you can do your dance program yourself. You can write a few lines of codes and you can do it yourself. Okay, so just imagine, this is the power of software driven car, and believe me, apart from Tesla, none else could do it. Those auto companies who are 100 years into this, they are yet to do this. So a lot of work is happening by people out here. I have just told in a nutshell, but this is much beyond this. But I don't have time. Um, I think I am done with the presentation. I have just mentioned out here my whereabouts. If someone of you want to reach out to me, I have given my mail ID as well as my LinkedIn profile, so you can connect with me. I can probably give you some inputs if you have interest in all these areas. With this, I thank all of you, and I think I have just could finish. Maybe I will not be able to take too much of questions. Yes, sir.
Actually, thanks for your excellent presentation. So I will request the host to, if possible, unmute the participants so that if they have some questions, they can ask to.
So they are unmuted, sir.
Anubhav, sir.
So they are unmuted.
Okay, so actually the participants, if you have any question, I hope there will be a few questions from your side because it was a wonderful lecture, so informative, and definitely it was very interesting to me. Actually, I also work in this automobile area, that means teaching and the other activities, but I also was not aware of so much developments that have taken place in these years. So it was really a very informative and up to date lecture which I have ever found. So if any participant wants to ask for any question, any clarification, he or she may ask to Anupam Bhattacharya.
Absolutely. In case I think I also have a meeting now. In case I go another 2-3 minutes, I'll be there. I have given my mail ID, so anybody has any question can mail me. I'll respond.
Yeah, that is a very good solution. So
Yeah.
actually, I must thank Anupam Bhattacharya for his contribution, excellent contribution and excellent speech which he has given. This talk was really helpful to all of us, and hope we will be again be interacting over the mail, and definitely it will help us a lot. So
Sure.
actually there is only an appreciation certificate actually that is yet to be signed. So we will send the appreciation certificate over the mail once it is signed to you. Okay. So
Sure.
we will hope we will be interacting again, sir. Thank you.
Yeah.
Thank you for your.
Absolutely, Mr. Ganguly. Thank you so much. And everybody
We are
else, yeah.
we are receiving also comments, very good, nice comments for feedback comments regarding your fantastic talk. So we are hopeful that such an informative lecture we could get. Okay, so definitely
Okay.
thankful. Thank you, sir.
Thank you. Thank you so much. And thanks everybody for your time and being patient in hearing what I said. Thank you.
Okay, sir.
Thank you.
As we have reached the end of this workshop, I would now request Mukesh Kumar sir to give the vote of thanks.
Hello, I'm audible?
Yes, you are perfectly audible.
Good evening to all. I feel honored and privileged to get the opportunity to propose the vote of thanks on this special occasion. I would like to thank all the honorable invited speakers, Mr. Soumyadipta Das, Mr. Avik Chattopadhyay, Mr. Anupam Bhattacharya, who gave their talk in this workshop in spite of their very busy schedule. I, on behalf of the organizing committee, convey deep regards and hearty thanks to our institute administration, especially the Honorable Director and all the deans who were kind enough to accord the necessary administrative approval for organizing this workshop. I would like to express sincere gratitude to the head of the department, Dr. Sudeep Ghosh, for his constant help and guidance that radiated a source of energy within us. We will ever remain grateful to you, sir. I would like to thank our session chair for successfully leading the session. I'm also thankful to SAE Professor in charge, Professor P.P. Desar and Dr. Aritra Ganguly. Without his guidance and effort, this event would have not been completed. I'm also thankful to Dr. Shantanu Das, who worked full time to host the WebEx platform. I would like to thank Dr. Bidut Palsar for publishing this event. I am very much thankful to all the faculty members and non-teaching staff who always stand by us and motivate us for organizing this kind of event. We have been fortunate enough to be backed by a team of very motivated and dedicated students, member and volunteer of SAE IIEST chapter, especially Muskan Singh, Tanishta Beg, Sushmiya Trivedi and many more who work day and night to make this workshop a reality. We are thankful to our sponsor, and it would have been impossible to organize this workshop without their support. Last but not the least, I would like to thank all the participants without whom this workshop is not complete. Finally, I would like to request all the participants to share their views related to the workshop. Any participant who want to share their views?
Actually, I think they are muted. You check, Professor Shantanu Das.
No, sir. They are unmuted. They can unmute themselves. I have given
Okay,
them
okay.
that option.
Okay, so actually, participants, you can unmute yourself. And if you have anything to say, you please state it without any reservation. And secondly, I think there is a Google form for feedback. So that also you fill it up and send it to us, so that if we have to organize some future workshops, we will be taking into consideration that. Okay.
Okay, I don't think anybody want to share their feedback. Uh, we have a Centenary lecture at 5:30 p.m. If anybody wants to join from the participant, they can join. The topic of the Centenary lecture is management romancing with corporate life. I think it will be a very interesting topic, and I request all the participant they can join. Thank you very much again.
With this, we come to the end of the workshop conducted by SAE IIEST chapter. We hope that you all enjoyed it and learned a lot from the workshop. Hope to see you all in the centenary lecture from 5:30 p.m.